we're going to begin. Hello, everyone, and welcome to the Artificial Intelligence Showcase. I am Asher Radensky. I am the Director of Operations for Deep Tech Showcase. Everyone can see my screen, right? Beautiful. Beautiful. Perfect. So today's agenda is opening remarks and meeting the panel is going to be the start of it. Then we have the pitches. So this event is a little unique because the first part of this event, unlike most of our other events, instead of having an open topic, we are having a selected but not funded. What that means, I'll get into it a little bit later. But that's followed by an artificial intelligence session 1 and then an artificial intelligence session 2. Our goal, as many of you already know and see, is to bring more deep tech to market. There are so many technologies out there that make sense, that should be commercializable, that should get traction. When it comes to the actuality, we see sometimes that expectations don't meet what we want it to do. So our goal is to help more deep tech companies get the traction they need by leveraging the power of a community. And so we created an ecosystem for deep tech only. And so it includes startups, tech scouts, investors, and tech scouts can be both from federal and corporate. And within the ecosystem, we have monthly events. And this month is the AI showcase. But at the events, we usually have about 3 sessions with each company getting a 10-minute slot per session. And that allows to have some companies gain some really good exposure. But that's not all. After the sessions, we like to promote guided introductions, which means that if you see a company today that you like or think that could fit in some sort of way into what you're doing, we're always happy to make the connection. As we said, it fits in with our vision. Our goal is to help make those connections and help more deep tech get to market. Just because there's so much out there and there's so much that we can be doing. Especially in today's day and age, with the rapid acceleration of technology, it just makes sense. So this is the showcase calendar. Ignore the June 30th. That's actually a typo on my end, guys. But today, don't worry, you're in the right place at the right time. June 28th, the third wave of AI. And then next month, we're hosting aerospace and defense. So stay tuned for that. And then after that will be communications and connectivity. And it goes from there. One notable thing here that everyone should be aware of or note in their calendars is that if you're coming to CES, we're planning to be there and to be hosting an event there. So yeah, keep that in mind and looking forward to hopefully seeing some of you guys at CES. And so this is the team, and you can see me front and center. And yeah, it's quite a lovely team, and we've been growing. So one thing we want to talk about a little bit and dive into is what are funding options for a deep tech startup? Where can companies find funding or find the right people? So some of these are very obvious, some of these are less obvious, but obviously angels, if you're earlier stage, angels are a great option. Venture capital is always good. Corporate venture capital is even better because you have 2 different ways of going about it. And then the fourth one that I'm going to jump into just a little bit is federal funding, because especially with the current market state for people's portfolio companies, if you are a startup looking for funding, right now, even though the markets are slightly uncertain, what is still certain is the budget for a lot of these federal projects. So there are quite a few programs open now. The Department of Defense SBIR program, which stands for Small Business Innovation and Research. The U.S. Air Force AFWERX open topic is going to be open and is due August 9th, if I'm not mistaken. National Science Foundation, Department of Energy, EPA, and Department of Agriculture. And there's usually about 150 to $70 billion available for tech funding through the federal government. And just so everyone understands, because this is a good preamble for the selected but not funded session, essentially, most of these SBIRs or BAAs are phased, meaning that there's a proof of concept stage, followed by a prototype stage, followed by a phase 2B, which could be a StratFi, TACFi, or phase 3. If you're curious about the stuff, feel free to reach out to us. We're happy to educate. I'm just running through this to give you guys a good understanding. But the eligibility requirements are that there are under 500 employees, and the R&D needs to be performed in the U.S., and 51% of the ownership is of U.S. residents. And that, in addition, that you have to be usually less than 51% VC owned. But there's quite a bit of availability here. And to talk a little bit about the selected but not funded, it essentially means that the folks that are going to be presenting tonight went to a direct to phase 2. And for the direct to phase 2, they were told, hey, you have something really unique and really significant, but we don't have the budget for it now, but we do have the Air Force interest. And what that allows is that there are other DoD entities that can pick up the project. And that is the goal of the selected but not funded piece. So just to go a little bit into what is available, the National Science Foundation's open for submission now. Phase 1 is $275,000. Phase 2 is $1 million. There's a bit of a timeline. And then AFWorks is open both for phase 1s and direct to phase 2s. What direct to phase 2 entails is a memorandum of understanding from an Air Force end user, meaning that there's an Air Force end user saying, hey, we want to try this out once it's ready. Phase 1 is usually $75,000, and phase 2s are usually 1.25 million. But yeah, it's due August 9th. So now to get back to the selected but not funded, to come full circle, we're going to be hosting 3 companies that were selected by the Air Force with relevant use cases that were not funded. There's a unique opportunity here to work with a company that already has a U.S. Air Force interest in use case. So what we have here is Unspun, ChemCubed, and National Energy. And the selected but not funded panel is including Marita McGinn, and Mara Leland Holcomb, Dr. Destry Grogan, Owen Sanford, Tim Crane, Olivier, Jerome York, Amir Ben Levi, Reese Schroeder, and Deidre Williams. And then the next session after that is going to be the first AI session, where we'll be joined by Gel Site, Monumental Gaming, Consilience, and Errol Marengo. And we have some repeats and some fresh faces for that panel. And then the second AI session, we're going to be joined by 9High, BlueMind, Orb AI, Cortical, and Connexio. And we'll be joined by the final panel there. Okay, so without further ado, I am going to stop sharing. And what I want to do is I want to open up the floor to the panelists. I'm gonna give you a little bit of a curveball to the panelists. I want to ask, first of all, name, company, obviously, what your focus areas are, and then also if you're okay with answering this, it's what you think of the current market and where it's going, especially in the context of deep tech. So without further ado, I'm going to put Olivier on the spot to start us off.
Okay, thank you very much. So I'm going to try to play the game. So I'm Olivier Demand. I work at Kino Finance, and basically what we do at Kino Finance, we help deep tech startups to accelerate their growth with non-dilutive financing solution, such as venture leasing, whereby we basically empower hardware as a service business model, and we participate also in equity run on occasion. So to answer to your question, Hetcher, I think having seen from the large scale M&A and the private equity side from all my colleagues and my previous life, this is pretty frozen. We see still quite some activity at very, very earlier stage, such as seed and pre-seed, whereby the development of the technology will take enough long time, given that those VC believe that throughout their investment thesis of 5, 7, or 10 years, would go out of the recession, so it's worth to invest in kind of deep technology at the moment. That's my humble opinion.
All right, we appreciate it. Thank you so much. Frank, you're up next.
Frank Levinson with Phoenix Venture Partners. We have both a seed level fund and a main fund that does Series A, B funding. We focus on material science, photonics, and biotech stuff as well, I suppose. So we do fundings in the range of anywhere from 250K to nearly 10 million across the life of the company. In those areas. Keep it short.
Thank you, Frank. All right, Tim, you're up.
Who are you talking to?
Hey,
Tim Crane. Yep, that's
hey,
you.
So, yeah, Tim Crane, just retiring out of the Army Futures Command, was the Strategic Partnerships Director. Effectively, we made sure that our senior leaders were connected with companies, whether it was a startup or a large company. I think that kind of leads itself to looking at the question that you asked us about the markets. It's interesting because most companies that we've been talking to, whether it's directly in the defense space or something immediately tangent to the defense space, are now opening their apertures, if you will, for M&A opportunities, other investment opportunities to hedge against any further downturns, whether it be in the markets or directly to supply chains. So very interesting time that we have ahead of us. But I look forward to the panels ahead.
Absolutely, absolutely. And we appreciate that. And Dr. Destry Grogan, you're up.
Yeah, so I'm Dr. Destry Grogan. I'm the Senior Vice President for CBURN Plans and Strategy for Patricio Enterprises. So my focus is really in the chemical and biological defense capabilities and the health markets right now. So working with the vaccine technologies and everything that came out of Operation Warp Speed. And so what I'm looking for within the market is those crossover technologies. How do we use those other things that come into these markets or come out of these markets to provide capability? In my last position, I was with Army Futures Command, just like Tim Crane, and I was working with the synthetic training environments. And there's a lot of application in modeling and simulation and how we bring those tools to other areas. And so those technologies and AI start to play into how we actually adapt those technologies to future uses that might not necessarily be obvious right now.
Sure, absolutely. Okay, perfect. Thank you, Doctor. Next up, we have Reese Schroeder.
Good afternoon, everybody. Reese Schroeder. I am from Allstate Strategic Ventures based in the Chicago area. We are the corporate venture capital arm of Allstate Insurance Company. And what may surprise you is about 10% of what we do is insure tech and fintech. But a lot of what we do is really deep tech and frontier tech. And so that's where I spend a lot of my time, is in that space. AI is a real important technology for our business. My expectations, as you can see, I've been around for a while. I've been doing corporate VC for about 21 years. I think it's a little bit of deja vu all over again, and I'm expecting personally, this is just my personal opinion, that we're probably going to see a down market for the next 12 to 18 months. And during that time, some great companies will rise, some will fall that aren't as great. And I think there will be a lot of M&A activities going on during this time. And anyway, that's, like I say, my personal opinion.
Yeah, got it. No, that makes sense. And yeah, thank you so much for that. Next up, we have Jerome York.
Hey, everybody. My name is Jerome York. I'm the CEO of Cityside Venture here in Michigan and Birmingham. We are focusing on early stage investing. We have 2 funds we're managing for early stage investing, focusing on mobility, deep tech, a lot in the EV market, after all, in Detroit. My opinion, we see a big influx of money coming to early stage investing in Michigan, at least. And I follow my grandfather's advice, which was a very successful businessman. He said, don't listen to the news and don't read the newspaper. Life is pretty good. So we're focusing our core business. I don't listen to the news too much. It's more like a media circus than anything else. And in every crisis, there's opportunity. So we've been there before, and everything is gonna be fine.
Got it. Got it. Yeah. Thank you, Daron. Happy to have you. Next up, we have Ann Merritt.
Hi, good morning, maybe afternoon and evening for sure, to all of you. I'm Ann Mara. I lead public healthcare at Splunk. Splunk is a $3.5 billion NASDAQ traded company, data to everything cybersecurity, and super excited to be here. Asher is an awesome partner to have on your journey to your exit, whether that's an IPO or an acquisition. We have within the Splunk family $120 million venture fund that we utilize to make investments and acquisitions. So happy to talk to any and all of you on that. We work and look at making investments across all deep tech verticals and areas of technical specialties, whether it's AI, robotics, energy, transportation, healthcare, across the board. And my prediction, and this is mine, nothing to do with a statement that any, as myself as a Splunker would be making. This is just me and me alone. What I hear from a number of VC friends, investment bankers, and private equity folks around the globe is that there is still, tons of money sitting on the sidelines waiting to be deployed. So if you've got a killer app, you've got a technology that is either going to save billions of dollars or make billions of dollars for any market that you're targeting, there's money to be launched and available to you. But I do agree with some of my colleagues here on this panel that we're definitely here in an economic time that is absolutely challenging. We've had 13 years of tremendous growth, and everyone, quite honestly, is exhausted. The last 2 years, I don't know how many of you, with a raise of hand, actually took a vacation, right? I know I didn't. I just sat on Zoom all day long and all night long. So I think that there's a combination of exhaustion, and so we're in the adoption maturation curve at the peak. But I think that also then just means that the next 10 years, the next decade, will welcome net new startups and ideas like yours and take us into the next frontier. Thank you, Asher, for having me today.
It's always a pleasure, Ann, and thank you. You make me sometimes appreciate it. Next up, Yan Liu.
Thanks, Asher. Hi, I'm Yuan from Hypertherm Ventures. So we are the CVC under Hypertherm. We are an advanced manufacturing company that's headquartered in Hanover, New Hampshire. It was a startup in the garage, born out of Dartmouth College. Our founders, alma mater back in the 60s, the OG startup story back then, and we grew into this global leader in industrial cutting nowadays. And so as a CVC, we look into the industrial applications of deep tech and thinking about how that could really bring forward Industry 4.0. So we look into areas including AI, machine learning, IoT, robotics, automation, 3D printing, and advanced materials, and etc. So early stage, from C to Series B. I think this is a great question that you brought up, Asher. I think I'm excited about this is in a way I feel like this is an exciting time for corporate VCs. Actually, I think for the last couple of years there's been more and more momentum and more CVCs coming up and more actions. And in today's interesting time, right? Like that there are unique strengths and resources corporates have that might be able to fill in certain gaps and able to support certain startups that might not be able to get fundings in the future, or bring in different opportunities, customers, and different resources that could help them survive a difficult time. So I think I'm looking forward to seeing more opportunities and maybe more opportunities to work with collaborate with different investors in the field as well.
Thank you, Ian. All right, next up we have Paul Milburn.
Hi, I'm Paul Milburn. I'm with New World Angels. We are a angel network based in Florida, but we do investments across the United States. I co-lead tech investments. I'm trying to move us a little bit more into the tech space and have particular interest in IoT, machine learning, and AI. And particularly excited about generative and conversational AI, but also any kind of Web3 technologies. So, but we have a very broad investment thesis. We usually invest in companies with valuations, pre-money valuations of less than 20 million, but we can lead and do lead and work with our partners in the VC communities as needed. And I've been looking forward to today for a while because hopefully we get some really hot AI companies today. So,
Absolutely. Thank you, Tal. And God bless you. Last but not least, we have Joseph Freyr from the U.S. Air Force. Joseph, you there? All right. I'm not sure if Joseph can hear us or not. Joseph, when you do get on, feel free to introduce yourself. And it looks like Champ is joining us as well. But in the interim, while we have a few more panelists joining us, I'm going to ask Beth to present. Beth is presenting from Unspun, and she's going to tell us a little bit more about what they've been rolling out. The floor is yours.
Thank you so much, Asher. I'm sharing my screen hopefully now. Let's see. And really great to be here. Thank you to everyone for joining. We're Unspun. We make on-demand and mass customized clothing production possible. So this is an image that is not computer generated. This is a real thing. You might recognize it. This is the Atacama Desert, and this is what the clothing industry looks like now. It's extremely wasteful. It's very inefficient. And we make about 100 billion garments per year. And it's said that about half of what's made will go to landfill within a year. So there's something that's very broken about this industry. What we want to do at Unspun is be more intentional. We want to change the industry. We want the clothing to be made after someone purchases it, and we want the clothing to be made for them. So we are making this on-demand and this mass customized apparel industry possible through both software technology and hardware technology. So here's some images of our software. What we do is we take 3D body scans. That could be a body scan that someone takes with their phone at home. It could be a body scan that someone takes in person. Like we have some stores, one in Hong Kong and one in San Francisco, where people can use a scanner. And with that, we turn it into a perfect fitting pattern. As you can see here, we've worked with jeans in the past, but we're able to work with anything that could use a pattern. So we just went over very quickly the software that we've created, and that automates the pattern making process. We're also building hardware that automates the production process. So this is not a real picture, it's a rendering. It'd be really cool if we could build this way, but this does kind of give you an idea of how we're able to automate clothing production. This shows off our 3D weaving tech, and what we've built is a machine that takes in yarn and creates and kind of 3D weaves it into a final garment. So very similar to 3D printing, but for clothing and in a very commercializable way. here are some example products that we've made from our machine. It's a little bit hard to tell here, you kind of have to see it in person, but these pant legs are seamless and they're 3D woven and they are very programmable. Every single warp yarn is on its own control. So there are a number of advantages to the technologies that we're building to make on-demand possible and to make mass customization possible. One is speed and efficiency. Right now, if you want to make a pair of pants, you can do it with the cut and sew traditional process. And you could do it with 3D knitting, which is really not done for a number of reasons because of the properties of the material, but you could. And both take about an hour and a half to produce. With our process, we are at about 20 minutes. So it's a much faster process. Another advantage is localization. Because we've removed most of the humans, not all the humans from the process, we can reduce costs and onshore production again. Another advantage is the impact and the circularity that we bring with the process. We've stepped back enough to say, how could we do things differently? And so we've skirted a whole number of steps in the process and have been able to think about it a little more holistically. So in terms of impact, we've already achieved zero excess inventory. So because we flip the equation and start with the consumer and then make the product, we have no excess inventory. We've also, with the 3D weaving machine, removed the cut waste that you usually get with a cut and sew process. And what we're working on right now, which I'm personally very, very excited about, is the circularity, thinking about this as not a linear life cycle, but as a circular life cycle. And so we really briefly looked at turning yarn into a final product, but it doesn't stop there. When you're done with that product, you can turn that back into yarn again, and that can be reused. So we're trying to get to a point of not just reduction of impact, but also actual circular model. Another advantage that we've talked about very briefly was mass customization. So because this machine can work with minimum order quantities of 1, and that's the same as 100,000, it can be customized very easily. It's a computer. So that's another advantage that we have. And then for any kind of textile nerd out there, there are really novel product features here. So it's not just about the machine. You can also look at how this new manufacturing technique changes the material properties of the final product. So that's everything from like seamlessness to continuous yarn to thinking about material structures changing throughout a product. We've had a lot of traction over the past 4 years. From the kind of commercial side of our traction, we have a number of ongoing custom fit collaborations, most notably with H&M and with Pangaea. We've been selling direct to consumer with the custom fit software for the past 4 years. And then just last week, we signed our first contract on the 3D weaving. So that's really starting to gain momentum, and that's something that we're excited to finally close from body scan all the way to final production on. In terms of our funding, we've raised funding from venture capital and also from grants. So just over 10 million in venture capital investments. And we've worked with the National Science Foundation. We had phase 1 to 2B TCEP. We got as much as possible from that grant. And then right now we're working with AFOA, Advanced Functional Fabrics of America, in partnership with Soldier Center. And we're hoping to make some more connections as well. And I'll just throw in there, we've got a couple, we're very, very lucky to get a couple of Time Best Invention among some other awards. So today, the goal would really be to meet you all. There's some really exciting people in the audience today and a lot of applications. Some applications are relevant. I know for some of you, this might be a little bit left field, but would love to chat with you if you have any overlap in customization, if you have any overlap in on-demand or local production or anything recycling. Again, there are a lot of relevant applications here, from custom uniforms to conductive flight suits to bulletproof vests to product recycling. And you can contact Nick or me at the bottom there, and look forward to your questions. Thanks so much.
Absolutely, absolutely. Thank you so much, Beth. We're going to open it up the panelists for questions. It looks like Olivier already has one. So Olivier, you're the first to go. Go ahead.
Yeah, thank you very much. But, just one question, if you could give us a bit more details on the business model, because you will have a hardware part, a software part, and you mentioned that your customer would be H&M, and I guess the end user will use the app to basically design their own. So how would it all fit together?
Yes, awesome question. And yeah, as you can tell, we are building a lot of technologies and commercializing them in different ways. Our first business model with H&M was to set up a body scanner in their stores. This is specific to Weekday. So that's one of their jeans stores. It's a higher end store than H&M. Customer goes in, gets a scan, designs their jeans. We provide the algorithm, their manufacturing partner makes it. What that looked like was an initial fee for development and then a revenue share from there. And so our that's the initial one. Our end goal is to create microfactories, starting with the US and then eventually around the world. We want to decentralize the clothing production. It's really, really centralized in Southeast Asia right now. We want to localize it. And so we're looking at big metro areas to start where the consumers put a factory there. We're looking at starting with about 5 machines that can produce about 100,000 units a year, but we want to get up to microfactories from there. And so a little bit more detail on, you're asking about the business model. We work with other brands as collaborations. So they would collaborate with us. We would, as collaborations, sell direct to consumer, which is what we've been doing with them today. And then, like you had mentioned, they could do the body scan at home, or they could do it some other way. We also don't have to do body scanning. Like there are ways to make intentionally without the body scanning, but still be able to produce on demand after they've purchased it.
Yeah, very interesting. Maybe we should have a chat later on, because the type of you type of business and the business model we try to it's exactly where maybe we could help, that you have a hardware and you want to expand. But well done, thank you.
Dan, the floor is yours. I think you're muted,
Sorry,
Ann.
I had to unmute. Thank you. Beth, first of all, congratulations. I mean, this is a phenomenal success story, and making it into, the front cover of Times is absolutely an amazing feat. So congratulations. And this is exactly the type of disruptive technology that I was saying that there's, lots of money sitting on the sidelines to deploy. If I may ask, I mean, it sounds like, again, obviously, it's great that you've been able to procure the large name brand contracts within H&M and others, but this to me seems very much in the lines of, and again, I live in Washington, D.C., so you'll have to excuse my statement and what comes next here, but there's a lot of lobbying that goes on in the apparel industry to make sure that, the so-called big guys stay in place and in power. And this to me is absolutely needed and disruptive. But I can also see the other side of it, where either one of the big guys just scooping you up or, displacing you in some way. Obviously, I'm going to assume you didn't mention this, but you must have either patents pending and or patents in place, and you'd want to have that just to protect yourselves. And of course, from a valuation perspective, IP, commands certain multiples. What's your ask here for the panelists today? What's the biggest need that you have? I can certainly see there being a potential opportunity to collaborate and support you all from a lobbying legislation perspective, because this is very much the democratization of the textile industry is what I see in this model that you've shared here with us today. So thank you for that. And then, other just like one last technical question, if I may, maybe it's more of a factoid, which is how many of these articles can you produce per machine per minute? Thank you.
Yeah, great. Thank you so much for all of the feedback and comments. It's really helpful. I completely agree. Lobbying is going to be a big thing. We don't have the cash in our pockets to do any of that. Fortunately, a lot of the initial partners that we're working with are, or I guess it's just by default, they're coming out of Europe because they're in luxury, and Europe is typically the first mover on anything political, anything policy. And so, for example, France just, I think it was 2023. So next year, they're starting to make moves into it. There's a zero waste ban. So any brand that's selling within France can't have excess inventory. If they have excess inventory, they have to figure out what to do with it. And it's they can't just burn it anymore, which is one big option, one big direction they often go in. So that's something that's really helping us rather than these brands finding Band-Aid solutions. Not all of them, unfortunately, but a lot of them are starting to think, how do we nip this problem in the bud? Let's just not make the inventory to begin with. So that's really helping us. And so we are leaning into Europe for some of the, the initial boosts. And then I live in California. California is like the next mover after Europe typically. And so we're kind of following those, but always want to learn more about what's happening in the lobbying space. We're too far removed from it. And then an ask, an ask would be how we can get involved more with the government with producing for contracts. And so we're hoping to have more conversations to learn where the needs are. And so we've had conversations learning about custom fit for uniforms, or even actually how to green the production process as well is another thing we're learning about. And so we're kind of at that learning stage and trying to make as many connections as possible.
Excellent.
All right, last question goes to Tim, but you also have a lot of questions in the chat afterwards, Beth. But Tim, go ahead, the floor is yours.
Yeah, hey, Beth, fantastic. Thanks for the overview. Really quickly, as a follow-on to what Ann said, what exactly are you looking for? Like, why the government, right?
Great question. We are really set on, like, can we bring manufacturing back to the US? And so there are a few big retailers we're speaking with here in the US and want to have some solid customers who believe in keeping things here onshore. The partners we're talking with in Europe, we're excited about, and they're happy to support us in building our nano factory, our factory of 5 machines first in the US, but then they want to pull us overseas. And so we really want to have some strong, solid partners here, and ones that can hit those quantities that we really need to hit in order to have the impact we want to have. And so that's starting in the hundreds of thousands of units per year for, let's say, pants, could be an apparel product, getting into the millions in the next about 3 to 5 years.
Awesome, thank you.
Perfect. So Beth, keep an eye out on the chat because it looks like you have a bunch of questions both in the Q&A and the chat. But thank you so much, Beth. And next up, we have Daniel from Cubed. Daniel, the floor is yours.
Hi, this is Dan Slepp from ChemCubed. I am just getting to start the share on the screen here. I'd like to introduce you to our electrojet line printing. Essentially, we are a research and manufacturing company for additive manufacturing. We're specifically a materials company. Right now, these are our current market segment, and we are going to be introducing to you the advanced additive manufacturing of electronics in this segment. These are all our current market segments that we are currently in. We're about 8 years old right now. We do have 2 different divisions, nanocube divisions, which we make nanocomposite photopolymers for additive manufacturing for specific applications where large companies, first-tier companies to aerospace and medical would have us make special materials that aren't off the shelf. But by far our commercialized areas are in the electrojet and additive manufacturing of electronics. Why are we so interested in the printed electronics? Because we do feel that that is the low-hanging fruit right now, and it's the area that seems to be growing the biggest for us. And there's so many applications within additive electronics right now. And you can see the forecast for the market here. I'm going to go quick with you. I'm sure this will be available for you in the future, but we are growing exponentially. The benefits are because you could do rapid prototyping and customization and manufacturing of electronics that you normally couldn't do in the way things have been done for the past 50 to 70 years. Just as a quick review, the difference between additive and subtractive is that subtractive manufacturing right now in terms of PCBs and all sorts of flex circuitry is what is that involves a process of laminating and etching copper off a PCB board, and that just creates a lot of waste, a lot of hands-on lots of hands-on manufacturing, and generally takes a long time to get a prototype or even in manufacturing. What we're here to show you is a digital technique for multi-layer, multi-material digital printing solutions in electronics. As I stated, we are generally a materials company, and that's how we started, but we provide a full concept and full system, meaning materials and printers and processes for that. Why do we stand out is because of the materials. What we've developed is a nanoparticle-free silver conductive ink, and those people that might be familiar with printing electronics and is that generally speaking, up to now with the regular particle inks, you can't get the type of conductivity. It takes a long time to sinter and isn't very good for manufacturing. We've been able to use a reactive ink and be able to manufacture things within situ of the manufacturing capabilities of a printer. And we've been able to have UV curing dielectrics, so we can go ahead and build a unit from ground up on PCBs and flexible electronics. And these materials all work together. So we've also have developed a printer. The idea is that we're using inkjet technology so we could do multi-material printing and multiple printing across the board. So this printer right here is our first printer, which is 12 by 24 inches. We have just introduced a 3-foot by 5-foot flatbed as well. So you can see this, we're really going into manufacturing areas, not just prototyping. The applications that we're currently in and that these printers are out there, there's about 30 to 40 of these printers out there right now. Some are in research areas, most of them are in manufacturing areas, and not only in prototyping, but in small run manufacturing, and really address all of these different multiple applications within these confines. We have, in review, our materials are the driving force, but we also offer printing technologies. and to support all of these different processes. What we're here today is that we've had multiple funds. In terms of going further within this technology. Right now we're going to 2 direct-to-phase 2s. One for flexible electronics and flexible circuitry that we've collaborated with another company. We've been chosen, but but not funded. So we're going to be resubmitting, and what we're looking for is an end user. We are working with the AFRL in terms of a stakeholder, but we are looking for an end user to help sign an MOU so we can go ahead and resubmit our application in that one. We also have a second one for phase 2 effort where we're building a full system for pick and place from beginning to end, using other collaborators that have some conductive epoxy and an innovative way of attaching circuitry in flexible circuits.
Daniel, a 30-second warning, okay?
Perfect timing. I kind of went really fast. I know I did through this, trying just to give you a basic of who we are, what we do within this. So I'd like to thank everybody for participating and allowing me to introduce myself. I'm ready for questions.
Perfect. Thank you so much, Dan. All right, opening the floor up for questions. Feel free to just throw your hand up, raise your hand. Okay, Anne, you're the fastest.
Well, thank you so much for the presentation. And since I didn't see your face, I am blanking on the name. And that's why, like in a virtual world, a face and a name always help. Oh, there we go. There we go. Hi, Daniel. Okay, perfect. All right. So hopefully I didn't embarrass you there, and it's okay. You're among friends. Competition. Help me understand what the competitive landscape looks like, and kind of where are you in that landscape? So if you think of a Gartner 4-quadrant model, where do you all fit?
That's a good question. Right now, in terms of additive electronics, there's a lot of companies addressing it in multiple ways, not only in inkjet. I'm going to say our biggest competitor it really concentrates more on prototyping rather than manufacturing, and it just can't. So it's not really capable of doing fast printing. Realistically, they sell printers and equipment for about anywhere from $400,000 to $500,000, where our equipment is under $100,000. So competitively, we're a little bit beyond that. I just think we have a different focus. But I'm going to say that probably our biggest issue is just getting the market to understand what we're doing and to change the way they've been doing things for a very long time.
Okay. And are you working? Yeah, no, it did. Are you working with the VA by any chance?
No, we're not.
Okay. Find me afterwards, and we can talk after. I'm sure my other panelists have questions for you too.
Okay.
Yeah, absolutely. Thank you, Anne. Anyone else? Otherwise, we will continue with national energy. Thank you so much, Dan. Dan, if you want to add your email to the chat, just so that if anyone wants to get in contact with you, they can. Feel free. And yeah, without further ado, we're gonna have Dave presenting from National Energy.
Unmute here. Can you hear me okay? Just a quick comms check.
Awesome. And you can see my screen?
Yep.
Okay, fantastic. Well, let's talk some trash. So my name's Dave Robow. I'm the CEO and co-founder of National Energy. My wife likes to say I have an unhealthy relationship with garbage. As a company, we extract value out of everyday garbage. My CFO likes to say that we turn money into we turn garbage into money. So let me kind of jump into this because I know I don't have too much time. I'm an environmental scientist. I've been in this sector for about 2 decades. Most of my experience, about half of my experience, has been with the Department of Defense. And about 11 or 12 years ago, I got thrown into this garbage issue where the forward operating bases were handling garbage in what we call burn pits. We were basically digging holes in the ground, putting all of our garbage into these holes, pouring jet fuel over them and lighting them on fire, which sounds like a terrible idea, but that's how we handled it. So this led to obviously 3.5 million veterans with chronological disorders and other health impacts from this really unsustainable practice. So my team at Air Force Special Operations Command developed the first of its kind plasma gasification technology. So we understand how to commercialize this hard tech. And the system was really designed to take various different waste streams using gasification to produce things that we need in forward operating bases, things like energy, hot water for things like that. And this is where I realized that there's a potential to use garbage as a feedstock. And that's one where I, as a scientist, got passionate because we generate 300 million tons of municipal solid waste in this country every year. The World Bank estimates that waste generation globally is going to increase by 70% by the year 2050. So again, the scientist in me sees a problem that we can utilize this feedstock to generate different things that we need for society. So we leverage these technologies to be able to solve these environmental challenges. So we're moving away from this old linear economy, this kind of take, make, waste model, and incorporating more of a circular economy where we're finding new ways to utilize waste products as raw materials. So if you look at the incumbent technology, really what we're talking about are solid waste landfills. Nobody likes them, very difficult to permit, very, very effective at polluting land, air, and water resources, the third largest contributor to climate change. Some communities opt to install incinerators. In larger communities where you have a million plus population, we see a niche market where we can deploy machine learning robots to be able to sort through the waste and promote the circular economy while also reducing the labor burden and reducing pollution. And ultimately what we're trying to do, this is how most recycling facilities operate today, very dangerous environments. And even for somebody like me that loves garbage, this is a terrible place to come work every day. Very dangerous conditions, lots of turnover. Robots are really effective at being able to increase worker safety and also reduce the contamination that's in the recycling stream. So here's an example of a robot at work whose job it is to identify the material that's coming across the conveyor belt, and the computer tells the robotic arm what's coming across the belt, where to position, and then ultimately where to put that material. And what we're trying to do as scientists and engineers is get to the biogenic portion of the waste. So after we've removed the recyclable commodities that have value in the circular economy, we're looking to get to that biomass because we know we can meet baseload power demands regardless of what the weather's doing outside. So what we're able to do is really build in community resilience through the circular economy. So in this example, the organic material is going through an anaerobic digester. We're removing the impurities to get to this natural or renewable natural gas component to then fuel whatever that we're trying to do, buildings, electricity, transportation, and then also producing renewable energy credits in the interim. So the military gave us a contract under AFWERX to kind of find product market fit. We found 7 installations that really like this, what we call resilient energy microgrid, because we could effectively be able to power critical infrastructure for the Department of Defense. So we have a total addressable market focused just in the DoD of about $9.8 billion, and that's based on a contract value of about $34 million. So we have some significant revenue projections as we grow the company. We hope to close our round, close the 7 projects that we have in our pipeline, and then ultimately get to a Series A over the next 3 years. We've already been tested and validated. Like I mentioned, we won our first contract with the Air Force, and we do have an open round right now where we're looking to build out that MVP for the Air Force. So that's about it I put together for you. We have a great team of subject matter experts, and I'm hoping to take any questions that you may have. So if you have any, I'm at your disposal.
Perfect. Perfect. Thank you so much, Dave. That was awesome. Olivia, you're up, and then after that, Reese.
Yes, thank you, Dave. Always nice to listen to you. A great presentation. Just one question that you haven't mentioned much. It's more about competition, and very interestingly enough, today I was discussing with one of my colleagues that know this company, Recycle-I from London. I don't know if you heard about them, and are exactly the same problem as you, and trying to provide the same solution. So I don't know if you know them, or if you want to talk about more about competition here.
What was the name of the company?
Recycle-I. It's in the UK. So Recycle and I.
No, I'm not familiar with them. Yeah, I mean, this is a growing issue because garbage either ends up in a landfill, ends up in the incinerator, or ends up in the ocean. So there are a lot of companies that are now jumping into this space. So it's good to see that there's been a real focus here.
Yeah. And apart from them, how you know some other competitors, or have you done a competitive landscape analysis, or can you talk a little bit about it?
Yeah, there are a few companies that are using a different process, like fast oxidation and some different technologies that are trying to get to the same problem, turning garbage into something more valuable. I would say there's probably about a handful of creditable companies that actually have some projects deployed and have some traction in the space, but it's a global market. I mean, every man, woman, and child generates garbage. So we're still in its infancy right now.
All right, thank you very much.
Thank you for the question.
Hi, Dave. I was just curious, like, who would be some of your target commercial customers for this business? I'm thinking like maybe food processing, things like that.
Yeah, that's a great question. Because we're small, 20 to 30,000 tons per year, we can typically go into a large college campus. We're talking to some theme parks in Orlando that have some strong ESG goals that don't want to put material into the landfill. There are some companies that have made pledges to zero waste to landfill. I could see, big tech companies interested in kind of an on-site solution to be able to, number one, handle their municipal solid waste and recycling, and then at the same time benefit from the renewable energy. So it's kind of those smaller companies, campus style, military installations is obviously where we're focusing right now, but small cities, we're in contact, we're in tertiary markets talking to, some smaller cities that are interested with a solution like this.
Thank you. Jerome, if you have a question, go ahead. Otherwise, okay, Jerome, you're muted though.
I think somebody already covered the question.
Okay.
See if this can fit in small cities that want to reduce the waste and also offset the energy cost.
Yeah, and I'll share with you that our Air Force customer was interested because inside of about 3 to 4 acres, we can generate about 1 megawatt of electricity. So to put that in context, if you were looking to do solar, you would need about 8 acres to be able to have that same amount of output. And of course, you'd be dependent on whatever the weather happens to do, where here we can meet baseload power demands in a very, very compact solution.
Perfect. And you're up.
Hey, thank you, everyone. Yeah, great job as always. Dave, great session here today. I think most of my questions were asked as well. I think if anything, really, it's just kind of where are you all in terms of, your road to revenue projections. I don't know if there was some number that you had in mind that you were, if we grow to this point, then we'll consider our exit. You don't have to give us the raw numbers, but are you 10%, 20%, 40% there?
Yeah, so right now, as I mentioned, we do have an open seed round. We are trying to build out our MVP. Of course, we won our phase 1 contract with AppWorks. Our phase 2 contract got us to this showcase. So you know how that panned out. But we are in talks with DARPA right now, who has expressed an interest in potentially funding the phase 2. But right now we are actively fundraising, trying to get out that proof of concept to, we all feel that our line of second customers is very, very long. But as you all know, getting that MVP out to the marketplace, it has some challenges. So that's where we are right now. But we have about 7 or 8 projects in our sales pipeline for 2023. So we feel pretty comfortable that once we close this funding round, we'll be able to move forward on those projects.
Okay, fantastic. Thank you.
Thank you.
Perfect. Perfect. Thank you, Dave. Feel free to, yeah, absolutely. Feel free to leave your contact info in the chat. And so that anyone who needs to can contact you. And so the next up, we have the first AI session. But before we get into that, I wanted to introduce some of the new panelists who joined us. Joe, are you able to, Joe Freyr, are you able to, I know before I think you were having some audio issues, are you able to introduce yourself and talk a little bit about what your interests are and where you see the market going? Oh, I can't hear you, Joe. Can anyone else hear him? I'm gonna take that as a no.
Are you on mute?
It doesn't look like he's on mute. Looks like it might be something else.
He's muted. His phone is muted.
All right, Joe, is it okay if we come back to you? Just let us know when you got it connected. Okay, so in the interim, we have Amir and Levi from Labs02. Amir, you want to introduce yourself, what your interests are, and then talk a little bit about where you see the market going. That's the icebreaker question we got going.
No problem. First of all, good to be here. I'm joining you from the faraway Israel, so it's 9 p.m. at the moment here, and I'm alone at the office. So I hope it's worth it. Just kidding. In general, we are early stage fund focusing on deep tech companies. We are, if I don't know if you're familiar, we are our crowd's early stage fund, which is very one of the most active funds in Israel in general. And you ask about the market, right?
Yes.
I believe that in the end, innovation wins always. It always have been. So, but I do believe that we are facing a couple of rough years, at least 2 years. However, because I am in the early stage, field, so I believe it's a great opportunity for new companies, and it's a great time to be a seed investor, because our companies are looking 5, 6, 7 years ahead, and I believe by the time we get there, the market will recover hopefully. So that's my perspective, at least.
Absolutely. No, thank you so much for joining us. And yeah, I do hope it is worth it. Indeed. Next up, we have Champ from Creative Ventures. Hey, Champ, if you want to, again, just so you remember, for your name, what you're representing, what you're interested in, and then what your outlook on the current market is, are the questions we have for this.
Yeah. Thank you, Asher. Hi, everyone. I'm Champ, one of general partner for Creative Ventures. Co-founded fund about 7 years ago. We're an early stage deep tech venture fund investing at companies utilizing advanced technologies to solve labor shortages, climate change, and the rising cost of healthcare. So those are sort of the three areas that we look at: automation, climate change, and healthcare. All of the teams have dual expertise on both the business and investment side as well as the technical side, and we deem them to be very, very important for diligencing deep tech companies and working with them. In terms of the outlook for the market, we have not. Interesting on the deep tech side, we have not seen nearly as much of a drop or challenges, especially in the seed and the air stage that we have been investing in. There's obviously a lot of changes on the late stage, but contrary to what a lot of people sort of believe in, we think that most of the impact or most of the expectation of the impacts have already been priced in, and we don't expect that much more significant drop. Given that in mind, we do look at valuation much more closely, and this is probably the first year that I've looked at that closely, even compared to last year, because we're definitely seeing that the corner being turned. But in terms of how we're thinking about it, if those impact would have been priced in, it would have already been priced in, as opposed to just people waiting for 6 more months to price it in. So we don't anticipate that much of a winter compared to a lot of other people, I would say.
Got it. Thank you so much, Champ, and we're really happy to have you here. Perfect.
Yeah, sure.
Absolutely. Next up, we have Marita McGinn from Silicon Valley Bank. How you doing, Marita?
Hi, doing great. Really happy to be here with all of you. My name is Marita. I'm a VP here on our Boston startup banking team at Silicon Valley Bank. I work with all sorts of different early stage companies up until typically their Series A. SVB in itself backs the majority of venture-backed startups in the United States, and we bank about 75% of all VCs in the United States, so very well entrenched in the venture community. And my background is in all sorts of different early stage startup development. Probably relevant to our conversation, I manage the Air Force Accelerator with Techstars. Let's see here. I'm interested in connecting with any sort of early stage company who wants to learn more about the Boston tech ecosystem. And in terms of the market, I'm definitely echoing Champ, so I'm probably going to steal your words a bit, but same here. We're seeing early stage companies, the startups that I'm working with, not seeing too much of a disruption in their fundraising. It's much more focused on the later stage companies who have really extensive valuations. So yeah, but that's my spiel. Very nice to meet all of you.
Perfect. Thank you, Marita. And we're gonna try Joe. We're gonna try one more time. Let's see if it works this time.
Yeah, sorry about that. I switched over to a new device. You can hear me now, I guess.
Perfect. Loud and clear.
Great. Yeah, third time's a charm. So hey, name's Joe Freyr. I work for the Air Force Office of Commercial and Economic Analysis. We are a shop that does market research. We're not an acquisition authority. We're not AFWorks, but we support AFWorks and AF Ventures. So I am interested in everybody who's applying for those awards. We also provide evaluation support to AFWorks. So a lot of us at OSEA are evaluators for those proposals as well. My specific focus is on AI and quantum technologies. So, within AI, I spend a lot of time thinking about the what I call AI core, but the tools you use to build and deploy AI corporately, and then a lot of time thinking about robotics, because that seems to be the military's primary favorite application of artificial intelligence. So so that's me and what I do. Also on the quantum side, focus on quantum computing and sensing.
Perfect. Thank you so much, Jeff. Next up, we have Rajesh from Applied Ventures. You're muted, I think. Rajesh, you're muted.
Of course, I gotta do it once a day, right? Hi, nice to meet everybody. Good morning, good afternoon, good evening, wherever you're in the world. I appreciate the opportunity to participate in this panel. I'm with Applied Ventures. We're the corporate venture arm for Applied Materials. We're one of the larger semiconductor equipment manufacturer. That was our, history. What we're looking forward to in the future is transitioning from being a pure equipment manufacturer to being a an enabler of materials processing technologies in the semiconductor and adjacent areas. Our investment areas tend to revolve around the core, which is around precision materials processing. So if you think of any application that requires you to deposit, remove, or modify a thin film on a substrate, then that's a potential opportunity that we'd be interested in investing in. We invested fairly widely. Our current areas, other than the core, tend to be around engineered optics. We're investing in companies that are developing devices for AR and VR applications. There are investments we make in the AI space, including chips for optimizing workloads and things like that. Quantum is an area of increasing relevance to us. We have technologies that can use to make the quantum bits, but we're looking at investing beyond just the bit itself. We're looking at software companies that can help enable quantum computing to the operating system and the middleware of quantum stack as well. I'm not going to pretend I know anything more about the market than the people before me. Just take a dartboard and throw a dart, and there's a probability they're going to be right. The heydays of valuation are already contracting a little bit, as you can see. That's what I see in the companies I'm working on right now, and the deals I'm working on right now. So who knows? People thought the world was going to end 2 years ago, and then the party still lasted. So we'll see.
All right. Well, thank you so much, Rajesh. And then we have Angie Foss from Autodesk. Angie, you're up.
Hi, thanks for having me. I missed the prompt of all the things I'm supposed to say, but I figure a good intro and like the things we're interested in at Autodesk Research. Does that sound right?
That sounds good to me.
Okay, yeah. Angie Foss, I am a network development manager for Autodesk Research. We have a lot of things going on in Autodesk Research. Both our research colleagues working on things related to automation, both in construction, manufacturing. So really interested in those sectors. And then we also have a residency program for external teams to come into Autodesk and help further develop their innovation and boundary spanning, pushing work. So happy to talk with anyone who might be interested in learning more about that. And I'm really excited to see what's on the panel today.
Perfect. Absolutely, Angie. Thank you for joining us. All right. I think this is the last two. We have Leland Holcomb. Leland, can you introduce yourself?
Hey, everyone. Yeah, sorry I came in a few minutes after my last call ran a little bit long, but nice to meet you. I'm Leland. I'm with Advanced CT. I wear a bunch of different hats, but work mostly with tech companies that are expanding operationally into the Northeast of the US through Connecticut. And otherwise, previously I worked in InsurTech in venture investing in InsurTech, early stage InsurTech companies. But now I'm more of a generalist, work with the state of Connecticut's venture arm, with our incentive arm, with our grants arms, and just generally. So good to be here and to learn from all of you and get to know you. Thanks for having me, Asher.
Happy to have you, Leland. And then last but not least, Ryan Hetcher.
Hi, yeah, Ryan Hetcher. I'm a run the engineering department for Ultra. It's a defense contractor, British defense contractor. At least for the moment, we just announced on Friday that we're being bought and going private. But my area is focused on command and control systems, advanced EW, RF, communication systems as well. So my background is I was a tech scout for Lockheed Martin, and interested in, I would say, generally advanced technologies that are pertinent to command and control in 21st century battle space. So specifically for here, AI is a big one. Leveraging the size and speed of machines in the modern battle space. Thank you.
Perfect. Thank you for joining us, Ryan. All right. Without further ado, the first presentation for the AI session, we have GelSite, and presenting for GelSite is Kimo. Kimo, feel free to share your screen. The floor is yours.
All right, let's go to my presentation. Here we go. You see the slides all right? All right. I'm Kimo Johnson. I'm co-founder and chief science officer at GelSite Inc. I'm going to tell you about our technology, which is being used widely in aircraft inspection today. I'll specifically focus on DoD, but obviously we have plenty of commercial applications as well. The cost and the expense for these platforms is just enormous. $100 million the cost of an F-35, and it's not just the upfront cost. In fact, 75% of the cost of this program is over the lifetime of these planes. But in the manufacturing side, at least 10% of this cost is in inspection processes. And there's just a disconnect between the type of technology that's going into it, the sensors, the sensor fusion, the advanced coatings on the wings to make it a stealth platform, as compared to the types of tools that you see when they're assembling and inspecting these. It's not uncommon to go down to the factory floor and see people, when they're installing components in it, looking at the component, scratching it with their finger to decide if a scratch is in or out of spec. These types of processes can be greatly improved by having digital maintenance and inspection tools. But as I said, the upfront cost is one thing. It's actually the maintenance cost over the lifetime of the program that's really astronomical. $1.3 trillion is estimated to be the cost of this program. And corrosion is a significant element of this. The DoD spends $10 billion a year fighting corrosion. And what's fascinating there as well is that at these maintenance depots all around the world, the tools that they have to deal with corrosion, to assess it, are incredibly primitive. So what we've really discovered is the fact that human hands are still a critical element in many different industrial processes, whether it's inspecting components, people feel it with their fingers, whether it's trying to make basic measurements with primitive hand tools, or maybe sometimes there are tools for inspecting some of these things, but they require high amounts of training. Like, for example, eddy current for inspecting cracks on aircraft. What's really needed in this space is an investment in technologies that can modernize maintenance and inspection workflows, and that's where GelSite comes in. We have a handheld tool that can precisely characterize and quantify surface topography on any surface that it touches. The technology is something I developed during my postdoc at MIT, and it uses a unique material that we call the Elastomeric Sensor. You press this up against any surface, and we can instantly get the 3D topography of that surface as a digital image. It's a measurement of the Z height down to microns of any type of surface deviation. We have patents that we've licensed from MIT, and we filed additional patents on our own. The key way that this technology is used is as a handheld tool on the factory floor. When inspectors sees an issue on a part, like a small scratch on the surface of an aircraft or on a component, they can press our tool up against it and get a 3D measurement within seconds. This is a digital measurement that can be archived, it's traceable, it can be mined later and put into use with detailed analytics. And it's actually the combination of these digital measurements and AI that gets us very excited. We have a new program kicking off later this year for looking at corrosion and how can GelSite do early prediction of corrosion on aerostructures. We have some early results here showing a GelSite measurement of a corroded fastener hole and using AI models to predict the corrosion level and start to give much more information about what's going on that surface and when it might need to be maintained. How does our technology compare with other competing technologies? Well, fundamentally, it is a tactile sensor. It does have to touch a surface, but in the space of tactile sensors, we have orders of magnitude more resolution. The technology was originally inspired by this idea of what it would be like if you had cameras inside your skin and could touch and see what your skin is touching. So compared to the kinds of capacitive sensors and others that exist, we're a very different type of technology. It's also image-based, and that gives us a unique advantage that we can apply many of the deep learning pipelines and image processing technologies that have been developed over the past decade, which gives us a leg up on the competition, especially in the space of tactile sensing. As a company, we've made good inroads into aerospace, space launchers, automotive. We do have systems within the DoD primes being used for actually new product inspection, but the maintenance opportunity is what gets us very excited because that's where the bulk of the measurement needs will be over the next 50 or 60 years. We've also been successful at attracting government funding for developing our technology further. We're currently wrapping up a phase 2 SBIR through National Science Foundation. We're also involved in the advanced robotics for manufacturing industry, taking our technology and putting it into an automated inspection platform. We have a very strong leadership team. Myself and Janos Rohai are co-founders of the company. A few years back, we brought on board Sherry Mantell as our chief business officer, and he's spent over 20 years in the aerospace industry, as well as automotive industry. And last year, we recruited Yusuf Benmokar as our CEO, and he's had extensive experience in business development, most notably at Magic Leap, where he helped raise $280 million for a strategic partnership that they did. So we are currently raising money. We are looking to raise 15 million to help expand our software architecture and add AI capabilities, to grow our commercial team. We only have about 3 people on the commercial team today, and to generally scale up the operations. We have an impressive list of current customers using our system. As I said, over 100 systems deployed so far, but we need to grow the company. And we're at a point where we've built out the engineering team, and now it's time to scale up sales and operations. So we are certainly looking for investment, but we're also looking for companies who have interesting applications where they need high resolution 3D surface measurements. We have a handheld device that can be used in a lab on the factory floor. And we've found diverse applications everywhere from measuring skin texture to automotive textures and elsewhere. So very interested in those types of opportunities and even strategic partnerships. So I'll end there. I know these are quick talks, but happy to go into detail on any aspect of the technology or company or answer any questions that you have.
Perfect. Thank you so much, Kimo. Opening up the floor for questions. It looks like Jan has the first question. Go ahead.
Me, right? Yeah, hi, this is Yuan from Hypertherm Ventures. For those of you who weren't here, we are a corporate VC under Hypertherm, and advanced manufacturing company. So this is really interesting because we've been looking into robotics automation startups, and what seems interesting to me is that like you go way beyond the traditional, like just of the tactile sensors, right? You get the data that's about you could get the texture of the materials and all these other information that not necessarily applicable, right? So I think that could be applicable to some of the questions that we are thinking about. But my question for you is, how does that really how does the data compare to, like, say, computer vision though? Yeah.
That's a great question. So it is fundamentally a tactile sensor. But the unique aspect of it, and I come from a background of computer vision and image processing. That's where my PhD is. Our technique actually solves one of the hardest problems in computer vision, which is how can you know what the surface geometry is without being influenced by the optical properties of the material? If you're just talking about image-based 3D measurement, the optical properties can really affect the image that you get. If you're measuring a transparent glass object, you get a very different image than, for example, that same object if it were made out of metal. So how the material reflects light drastically affects the image capture. But with our technology, everything looks the same. You see my fingerprint looks exactly the same as this metal coin, looks exactly the same as this fabric. So in many ways, we've come up with a way of non-destructively applying a very thin layer of paint to a surface such that we can measure its topography to high-level precision. And that gives us a leg up over more traditional computer vision approaches for 3D geometry capture.
Perfect. Rajesh, the floor is yours.
Hi, Kimo. Are you primarily focused in terms of end markets? Are you primarily focused on the aerospace market? Or I think we spoke to you guys a couple of years ago.
Yeah, and actually we've had conversations since. I think your team has one of our systems.
Right.
There are applications in doing assessment within the semiconductor space, especially if you're dealing with materials that have translucency. You can imagine that there are abrasives used in semiconductors, and if you want to do imaging of those, our technology provides unique capabilities there.
Okay, so you're not averse to going to other markets, right?
We're about 50% in aerospace right now, but honestly, that's been a risk for us because with 2020 and people stop traveling and aerospace companies slow down their manufacturing, it did have an effect on our business and really pushed us to branch out into automotive and others. Okay. That's when space launchers started to pick up for us. But we're very interested in diversifying.
Okay, one technical question. So do you guys have a limitation, because I think you have a gel film that conforms to the surface and which you image on the back end, right? If I remember correctly. Do you guys have a limitation on how fine a feature you can resolve? I can imagine if you have a really fine, tightly spaced one, you might not get cast.
It's mostly an optical limitation on that side of the equation. The limitation is we certainly don't measure very large depth discontinuities. So when you're talking about big offsets, we don't measure that. But on the fine side, it's an optical limitation. We've demonstrated very good repeatable measurements down to a single digit micron, like 1 micron. Okay. As you get below a micron, you start to get into optical measurements that are non-optical. So we're pretty much, we say 1 micron to 1 millimeter is our sweet spot.
Got it. Thank you.
Yep.
Perfect. That's all the time we have. Thank you so much, Kimo. That was fantastic. And feel free to drop your email or LinkedIn in the chat for whoever wants to contact you, they can. Next up, we have Monumental Gaming. I believe Craig will be presenting for Monumental Gaming. Craig, when you're ready, the floor is yours.
Absolutely. There we go. Everybody, I'm Craig Olson in Seattle, and I'm with Monumental Gaming. And I have to say, following Kimo is a very difficult thing to do. Very impressive presentation and very exciting technology. Yeah, so we're a immersive gaming and game-based learning company. My background is game development and also hardware development. I was a game developer prior to becoming a hardware developer. And we were, I guess, recruited by Apple prior to the iPad coming out to begin developing multiplayer games for the iPad, which we did. We were the first, we developed the first multiplayer game, which was actually on demo iPads around the world when it launched. And our teams worked so well together with the folks at Apple that we began developing also accessories. And the accessories, I guess, what would be called the first app-enabled accessories ever developed for the iOS platform. We did several in the, I guess, family learning category and several in the gaming category. And it was very pre-market, but the gaming category resonated much more quickly. And so we ended up developing the first 4 or 5 wireless Bluetooth-based controllers for both iOS and Android platforms, and that also involved some co-development with Apple, under, I guess, great secrecy for quite a bit of time, and it was really a phenomenal experience for us to be able to develop at that level and also that scale. So, what are we doing now? Well, SealSeries, the company I've been at for 10 years, which was purchased by a PE company that had also made an offer for my previous company, hired me, and we were able to build SteelSeries from a very obscure European-based gaming company to becoming the global leader in many categories, including mobile gaming and audio and others. And so it just sold, and this is my new project. We do believe we'll become the global leader in immersive gaming and game-based learning. And what I mean by that is probably quite obvious. There are lots of tools today to create a super immersive environment, both for learning and for gaming. And I think many people have seen the movie Ready Player One or read the book. There's also Ready Player Two book, which is out, not a movie yet. But in that world, you might recall that the characters are walking around the real world wearing AR and VR goggles. Well, that's impossible because obviously the real world can't interact with the VR world. You'd run into buildings, you'd fall into cliffs, you'd fall into the ocean. We've created an environment that allows for that, and that's part of what we'll be developing. So, this is, I'm sure everybody knows this, but I think it's important to take a look at the growth of gaming over time. This is in billions, by the way. So, it used to be that movies and TV was the primary form of entertainment in the world, and music. Obviously, that's not the case anymore. Gaming is by far the biggest form of entertainment, continues to grow at about 13% compound annual growth, even though it's so large. As of the end of this year, there'll be about 3 billion gamers in the world, and that sounds like an astonishing number. Well, it is. You think about what people actually do with their devices, for the most part, it's gaming. And obviously, there's all kinds of other platforms that are more obvious game devices, but essentially, a lot of the world now is considered a gamer. And then, in parallel to that, the AR VR market will continue to grow dramatically, 63% compound annual growth, depending on who you talk to about it. I think more conservative growth is in the 30s. Nonetheless, it's going to be over $1 trillion market in 10 years.
30-second warning, Craig.
30-second? Okay, great. So, the idea of game-based learning, I think, is really taking off within the DoD, and many folks we're talking to about a phase 1 and phase 2 grant. And then obviously AI is imperative, and it's just a given in gaming. Not only gaming, but gaming devices, gaming things that allow gaming to take place in a better experience. So what we've done is create an environment where there's phenomenal training capabilities available, as well as the best possible gaming experiences that be possible. And there's all kinds of benefits for DoD, we believe, and amazing benefits for consumers around the world. So I'll stop here and take questions.
Absolutely. Kyle, you go. Go right ahead.
Yeah. So interesting to hear about the kind of the market and so forth, but I'm not clear on what the product is or products.
Yeah.
Is it a technology, a platform, or a product? Right.
Well, it's really both. We began this R&D effort about 4 years ago. We did some experimentation. Part of it was funded by SteelSeries, part of it privately. And we began experimenting with a decentralized, independent platform to be able to game. As we got into some experimentation here and elsewhere in the world, COVID hit and we put it on pause. And as we've emerged, we've realized that there's an immense opportunity using a combination of technologies that are already out there, only optimizing it for gaming and learning. And so our efforts will be centered around hardware and software development to support the various ways to enhance an immersive experience. So it's both a product and a technology.
So are you licensing? What's the $13,000? Are you licensing the technology if it's a technology play, and do you have?
This is consumer path, which will be essentially an immersive gaming pod, and it's a configurable pod that will range starting around $13,000 all the way up to really $250,000 or so. So it's kind of the ultimate gaming experience. We figure there's roughly 30 million people in the world that could probably afford something like this on a consumer basis, and that's the target market we're going after. That makes any sense. It's think about how gaming can be enhanced with the use of modern technology, modern projection, and even holograms, which we believe we'll be able to deploy.
Is there any MVP?
I'm sorry, MVP?
Do you have any minimum viable product at this point and any customers?
Oh, it's currently in testing, and it is with partners, but not technically not with customers yet.
All right, Ryan, go ahead.
Yeah, real quick. So for platforms like this, content is king. what's your plan for bringing in content developers, content makers into your ecosystem?
One of the advantages, I think, of being president of StillSeries has been the fact that I'm able to work closely with content developers all over the world for now, I guess, 15 years. And when we first introduced the idea of mobile gaming and gamepad controllers in the mobile space, we literally had to pay for content because there wasn't very much available, even on the iOS platform. And so I've had a chance to work with largest, most successful developers and publishers for a long period of time. So I really feel confident that we'll be able to do the same thing in this new category which we're creating, much like we created the mobile gaming category. I think we're in a very good position to have the very best content. And as you know, all of them have been working on AI based gaming for a long time. So that's just a given, I think, not only with the content, but also with hardware devices, which for a long time at StillSeries anyway, we've been using AI to drive a more fulfilling experience for consumers all over the world, many countries, I don't know, 135 countries maybe.
Perfect, Craig. Thank you so much. That was Craig from Monumental Gaming. Feel free, Craig, to leave your info in the chat, either a LinkedIn link or something else, because I think there was at least one more question that I don't think we necessarily got to. And that is exactly time. Sorry about that. Next up, we have from Consilience, we have Harry Loriken. Harry, the screen is yours. Feel free to share your screen on your end, and whenever you're ready, get started. Harry, I think you're muted.
Unmuted myself. You could actually hear me talk. So I'll start now. So it all started out with a problem. How do I digest the diverse science and see evolution of ideas where I can focus my investment thesis? I've been in healthcare and life sciences a long time. It is moving at the speed of light. And now that we're combining it with other areas or domains like technology, you have to look at multiple domains simultaneously to see where the puck is going. The idea was, can we create an engine that can digest all of science publications, create an interrelational data set, and also the dream was, can it show me where science is going next? What the team has built has digested millions of science publications, and we can actually now do almost any corpus of any size or shape and basically create an ontology on the fly that we can see the interrelationships of those topics and plot what direction they're all taking. So just to give you an idea, all of PLOS, all of Medline, some very large economic data sets, NIH grants, NHS grants, all US patents, a number of technology publications, and we can actually, in a matter of minutes, recalculate these sorts of large data sets and then be able to show you through a web interface how things are interrelated and where things are headed over time. So questions we try to answer are, what are the hidden relationships? What are things that are going on in the background that we can't calculate? What are the ideas that have appeared and then stuck around or faded away? We don't want to be investing in things that have a downward trajectory, or be looking at something that's taking us down a rabbit hole or the wrong direction. What are the key signals telling us? What is likely to make the next move? And can we predict what's going to move to the top of the leaderboard? And so here's an example of science. So this is proteomics. If you guys are not familiar with it, it's a subset area of protein analysis. And on the left, we have 24,000 papers over a time period from 1993 to 2001, where the machine will automatically plot the interrelationship of everything that's in those papers. It will also tell us in the upper right-hand quadrant the emerging areas that are moving within a subset of those, so that we can sort of hyper-focus our attention on those areas that are moving the fastest. And as you can see in the bottom left, we can actually watch over time science moving on the leaderboard. So we don't have to guess the stuff that's at the bottom that will never come up. We can actually focus on the stuff that's at the top. And if you look at the right bottom quadrant, you can see that we can actually predict very highly accurately the movement of specific science topics with incredibly good accuracy. Another area is artificial intelligence, or the NeurIPS conference. We digested all of the papers that came into that conference from 1990 to 2019. The system automatically creates an ontology and the interconnection. And we can actually plot over time what's moving and where it's going to move within the space, so that we can hyper-focus our efforts on those areas that are of interest. And so, again, if you look at the bottom right-hand corner, we can pick a very specific topic and follow it through time, and we can predict it in 3-year increments before it actually gets to its final destination. From a defense or intelligence perspective, we've been actually able to look at specific papers and identify an adversarial country and what they're doing in physics versus what we're doing here in the US, to understand where they're spending their time and their focus. And then finally, where we've got the biggest traction has been in finance, where we've been able to, as you can imagine, if we could sort of tell people where things are going, they're willing to pay for that or access that sort of information. We can actually create whole processes where we can look at market themes and create, both through structured data and unstructured data, where the market is going and optimize a portfolio. If you look in the bottom right-hand corner, we've actually been able to interrogate all of Fed minutes, all their speeches, and be able to predict where they're going with market rate discussions, as well as in the bottom right-hand corner, all documents that are in Edgar. And so we can actually see where things are going. The competition is nowhere near, I think, utilizing the technology that we are at this point. The market is quite large. The area where we have the most traction, again, is in fintech. The team is very experienced. Everybody here has a tremendous experience in the technology side and creating these sort of complex systems. And in reality, what we'd be looking for is feedback, partner suggestions, and any comments that you have.
Perfect. Thank you so much, Harry. And it looks like you already have 2 questions. Tal, you're up.
Hi, a couple of questions. The integrated Corpora is marketed to whom? So who do you imagine is your buyer is, I guess, question number 1. And number 2 is it a service or is it a product that you're selling? Do you sell
right now it's
the integration or the result of the integration?
So right now it's a little bit of both, depending on who we're servicing. We're servicing a finance customer right now. They want custom products that they can take to the market that will outperform. So we have partnered with them to create those products. We've given them a few already, and we will be their continued partner in helping them rebalance that as time goes on so that they can keep that product performing at a certain rate. On the science side, it would be working with R&D groups, helping them understand where to focus their effort, helping them understand where not to spend their time so that they're not focusing on an area of science that is not going forward. So those are 2 totally different examples. For DoD, I think their corpus would be very specific to the question that they're trying to answer. So we would ingest that and then produce a result for them.
Okay, so in order to scale, does that mean you're going to add additional knowledge scientists, or how is it that you're going to be able to grow, given that's what you're looking to sell?
So we actually originally, when we built this, we thought we needed incredibly deep expertise in particular science areas. That proves out not to be true. We've actually brought the problem down to an engineering issue. So if we have a good engineer walk through the system, they can actually get to the answer, or I'd say 95% of the answer, until we have to pull in a subject matter expert that can take it that last 5%. So we can actually hire reasonably smart engineers that can take this very far within any project that we're doing for a client.
Perfect. Next up is Olivier.
Okay, thank you very much, Harry. One question in terms of data. So you put a mix of public and private data. So to the extent you go to private data, I mean data that you got from your customer, how long it takes basically to plug in your software, your algorithm to the client data and then to start working. So how long it takes the deployment, and maybe last question, how it works in terms of portability once you develop for let's say one industry, the fintech, some models that works in order to alleviate some problems, if then you can reuse it or reuse the model for another client.
So I'll give you an example of the Defiance, and then I'll give you an example of all of Medline. So all of Medline took a couple of days to ingest. It's 25 million publications.
Mm-hmm.
On the finance side, I think we ingested that and got done in an hour.
Okay.
That was their proprietary data set, because it very small compared to 25 million publications.
Yeah.
We can ingest very quickly, and then the processing doesn't take very much time.
Mm-hmm.
And then, again, on the finance side, we can zoom in and zoom out on the data incredibly quickly because of the dynamic nature of the way that we've designed the system.
Mm-hmm.
For anybody that understands the data side, we can recalculate all of Medline in about 5 minutes. And if anybody knows how big Medline is, that's not a trivial exercise.
Yeah, I see. Thank you.
That's awesome. Joseph Freyr, you're up. And then Angie is the last question.
Hey, thanks. So super impressive, really interesting technology you got here. So question is, I think two questions related to each other. First, understand, you're ingesting publications. Are you limited to written documents? And then if you're ingesting written documents, how are you assigning topics to them or assigning a keyword to them? And then second question is, can you also translate documents, or are you limited to a set of languages?
Okay, so I'll start with the last one first, because that's easy. It doesn't care about the language. Although if it's doing it in Chinese, I can't read it, so I can't test it out for you, right? So that's my limitation. When it comes to ingesting the documents, we absorb all the documents in written format through some sort of API, preferably, so that we can suck them all in at one time. The system will automatically ingest them, automatically processes them, and automatically create its own ontology based on what the system is reading in the documents, and create an interrelated graph that you see there. And then you can interrogate it. And then by assigning, putting in some specific words that may be of interest to you, you can have the system then hone in a lot faster.
Perfect.
I'll be fast.
You're up.
Okay, you briefly touched on your competitors. Can you just talk a little bit more about the differentiation between your work and some of your competitors?
Yeah, so a lot of the companies out there are either using, some form of, machine learning or Boolean descriptive. Like if you've done, publication searches, it's a nightmare trying to get to what you're trying to find. Ours is really elegant math. I mean, I don't know how else to describe it. It is components of artificial intelligence, but it is totally explainable and auditable on how it got to where it got to. It will automatically do 90% of the work for you. And you're just sort of tuning in to what you really want to look for, as opposed to constantly putting in keywords, trying to find the last scrap of what takes you to where you want to go to. And it automatically calculates the direction of the subject that you're interested in, as well as shows you third order emerging topics that you can't see. So if you think about it, it's calculating the derivative of the derivative to show you new things that are coming up that you wouldn't easily be able to find. Cool.
That's awesome. Thank you so much, Harry. Don't forget to leave some contact information in the chat. Next up, we have Marengo presenting, and presenting for Marengo will be Christopher, and I will be sharing their deck. So Christopher, whenever you're ready, feel free to go ahead.
Yeah, hey, good afternoon. Good morning, everyone, wherever you are. Next slide. I don't know if I can I switch slides there? There we go, perfect. All right, so one of the things that we've got here at Marengo, we're small. With my background in the Marine Corps, we have some background in various services. We've kind of recognized that the attrition wars that we hope to be able to avoid are here to stay and here to last. But one thing that's changed in this ever more modern battle space is that GPS denied. The current models for using drones don't scale, and we can't be efficient. So we have the ability to deploy high value, high cost systems, but the ability to deploy those in mass just isn't there at a low enough cost. The result of this is kind of what we're seeing right now in Russia and Ukraine, where you have a loss of lives and material. And then it's just like World War I, World War II, bludgeoning one another into submission. Next slide. So our solution to this is that we present automation as an augment to this, reducing the amount of burden on routine high volume tasks, creating digital twins of the battle space such that point clouds can be more meaningfully employed, and we can accelerate the decision chain. And this is something that is extremely important for anybody that's ever experienced warfare, is how fast can you make decisions at the right time and in the right magnitude with the right things. And so what we've focused on is the ability to use automation for those routine tasks in employing sensors, employing autonomous vehicles, such that you can accelerate an individual decision maker and make one squad a complete team in a way that usually companies or battalions are. Next slide. So it's secret sauce here. We've automation, as I mentioned earlier, GPS denied and digital twin analysis, but small group 1 UAS. We know that this works because it's being used right now with mortar rounds and artillery right now in Ukraine. It's been validated by the United States and other Western forces and Eastern forces all around the world. But what we've done is taken care of the logistics to allow for those drones to get out en masse. And so one vehicle and one operator can manage, in this case, 12 drones in the picture, but we have a 20 and 80 drone hive as well with our joint venture in Sentient Robotics. The other image is the actual link to the shooter. So that direct tie from the drone into the shooter. So we have a 105 millimeter howitzer that's self-propelled. This allows for us to shoot in a minute 25, and beyond the specifications there, it is a critical difference between the current state of 4 to 7 minutes to shoot one time and us to be able to shoot a minute 25. And this can scale to any type of platform. We already have, we're working right now in designs for the 155, the Brutus, that's being in production now, long-range rocketry, things of that nature. The challenge that we're addressing is how do you make this something that the squad can use and not just the battalion or brigade level. So giving the control of a maneuver down to the lowest level. Next slide. And the result of this is basically we've replaced that high level coordination and orchestration in a way that only Western type of militaries can leverage and maneuver. We've created something that will genuinely save faster than their enemy. And just like we learned in Tarawa, just like we learned in these battles in the past, artillery battles in the past, it's shooting first, shooting often, and shooting accurately is critical. So this isn't just something that's, obviously we didn't plan for the Ukrainian conflict to validate this, but it's being proven right now where the larger, more higher mass Russian army is inflicting heavy casualties on the Ukrainians, but they are disproportionately inflicting casualties because of their ability to shoot, move, and communicate faster than their enemies. And this isn't being done anywhere else in the world. It hasn't been done from the shooter to our software architecture that can control multiple drones, to the software architecture that controls the gun, to the gun itself. Everything being linked together. We're the only ones in the world right now that can do that without a higher echelon of control. Next slide. So the next one's about our milestones, where we've been. It's taken us 5 to 6 years to get to this point already. Over the past year, we've started deployment. The Army has bought 2. We have 2 more that have been ordered to go overseas, and we have another 50 units that have been submitted in an LOR that are pending approval. And we have no debt, 100% owned right now, and a service-disabled vendor-owned small business. Next slide. Again, this is going beyond artillery. This is going towards something that is designed to be able to scale into our architectures and designs of different applications when it comes to logistics and other things that require routine applications. This is where the digital twin will be more and more of an impact in larger scale operations. And our ask, we have a $5 million ask to productize this. We already are going to market as we speak. We have a product, but we need to scale it and we need to refine it for additional applications per military, NATO militaries, and so on. And that's it. If I have any questions, I'll throw it on the team to ask as you will.
Sure, absolutely. Thank you so much, Chris. Ryan Hatcher has a question. It looks like. Go ahead, Ryan.
Yeah, not surprisingly. So very interesting, very compelling. I would say a couple things come to mind just in terms of practical challenges to fielding. Getting this into a real program is certification. Have you talked to anyone about getting like JITC certified or AFSIT or whatever you would need to do in order to operate?
So
yeah.
Absolutely. So we're shooting right now at Yuma, Arizona. We've got around 3,000 rounds down range. This solves the physics of, like, rather than having drone carry a couple bombs and then drop it and come back, we're able to mass fires because the drone's carrying just the awareness, and then the fires are coming from the rear. But we're going through that characterization testing right now with the U.S. Army. The drones the only thing we have is the box that launches and recovers those. Our cybersecurity and those certifications are ongoing. We're right now CMMC going towards 3, but the ability for us to operate right now with our software architecture, because it's originated, we are able to transition right now into government use today.
Yeah, so there's two pieces. There's sort of the authority to operate side of it, which is your cyber, make sure your software passes on the scans and such. That's challenging but feasible. The other piece is getting certified for fire control in a battlefield. And there's also, which is going to be, just as a matter of course. So actually getting fielded is going to be very challenging unless you have existing relationships in the JITC and AFSIT and so on, which sounds like you do with the Army. The other issue is, have you thought about connecting in to existing tactical data links like Link 16 with network-enabled weapons? So being a network-enabled weapon system, is that, so in other words, leveraging existing infrastructure, command and control infrastructure I'm talking about.
The reason we built an application with infrastructure that controls our agents and low level execution of the drones. The software we use is either, we use US military, but we also use Arcfire, and that's kind of our preferred right now. Arcfire is adopted by Australia and New Zealand. That allows
Chris, you're cutting in and out. Chris, can you hear me? All right.
Mostly out.
Yeah, I would agree. So,
I'd like to talk to Chris offline if we can get some exchange of contact info.
absolutely. So yeah, I definitely will have that set up over an
Thank
email
you.
chain. And anyone else who'd like to connect with any of the companies, feel free to reach out to me. But I think we're gonna keep things moving. Thank you so much, Chris. If you can hear me, I know that the connection's not so great. So next up, what we're going to do is we're going to quickly run through the panel for the companies who have not, heard who you are and what you're looking for. It's just going to be quick: name, what organization, and what kind of tech interests. We're not going to have any crazy icebreaker questions. Just run through it one last time before the last third AI session. So Jan, you want to kick us off?
Oh, me?
Yeah.
Yeah, cool. Yeah, hi, I'm Yuan from Hypertherm Ventures. We are a corporate VC under Hypertherm, an advanced manufacturing company in headquartered in Hanover, New Hampshire. So small startup came out of Dartmouth back in the 60s. Now we're the industrial leader, a global leader in industrial cutting, and we're looking. We are as a CVC, we focus on. The deep tech applications in the industrial space, basically any early stage companies from C to Series B, and we write checks from 300,000 to 3 million. So applications could be robotics, automation, AI, IoT, and 3D printing, advanced materials, and etc. So yeah.
Thank you, Jan. All right, Joe, you want to quickly introduce yourself?
Yeah, I'll try. Oh, sorry. Who are we talking to?
Joe Freyr.
Okay, yeah, sorry. Name's Joe Freyr. Work for the Office of Commercial Economic Analysis for the Air Force. I focus on artificial intelligence markets and quantum technology markets, and deliver market research back to Air Force stakeholders, including AFWorks, as well as a handful of other offices around the Air Force and the Department of Defense.
Sure. Thank you so much. Ryan, you want to quickly introduce yourself as well?
Yeah, sorry, I'm muting. Ryan Hetcher, VP of Engineering and Innovation at Ultra, British defense company.
Perfect. Thank you. Tal Milburn.
Hi, Tal Milburn. I'm with New World Angels. We're a syndicate of angel former executives and former founders. And now it is the fastest growing startup ecosystem in the country right now, which is around Miami. And we look to invest across industries, but I focus on advanced technologies, particularly IoT, Web3 technologies, and AI. So
perfect. Thank you, Tal. Leland, you're up.
Thanks, Asher. So I'm Leland. I'm Director of Business Development, focused on technology at Advanced Connecticut. So I work with tech companies that are scaling into Connecticut. My interest here is it's pretty general in the types of tech, because we have a lot of aerospace and defense in Connecticut, like General Dynamics, Electric Boat, Sikorsky, Raytheon, Pratt and Whitney, you name it. So we do a lot in that space. But happy to be here.
Perfect. Happy to have you. Reese?
Reese Schroeder. I'm with Allstate Strategic Ventures. We are the corporate VC arm of Allstate Insurance Company. We do invest in a lot of deep tech and AI and machine learning. So very happy to be here.
Perfect. Happy to have you. Dr. Destry, you're up.
I'm Dr. Destry Grogan. I'm with Patricio Enterprises. I'm the Senior Vice President for Seaburn Plans and Strategy. My focus is really in the chemical and biological response areas and the health and medical markets at this point in time, and really looking for how we can get crossover technology into the defense space and support those endeavors.
Perfect. Happy to have you, Dr. Destry. Rajesh?
Hey there. I thought I went Rajesh with Applied Ventures, corporate arm for Applied Materials, based of the San Francisco Bay Area.
Perfect. Thank you for being here. All right. So first up in the AI second session is 9 High. Presenting for 9 High is Dave. Dave, the floor is yours. Let me just make sure that you can share. Yep, you should be able to share your deck.
Actually, Asher, do you mind putting yours up just in case I lose my video? It might be better if you put your version. Sure. If I have a difficulty, I'll shut down my video and then everybody can still see it.
Absolutely.
Sorry, hopefully I didn't catch you off guard.
I'm a little off guard, but it's okay.
Sorry. Just with the other problems with the other people, I figured that might be better.
Sure, that's fine.
Do you have it there, Asher? If not, I'll share mine.
Yeah, I'm pulling it up right now. It is about ready. Okay. All right, you're good to go.
Perfect. Okay, great. So, hi everybody. My name is Dave Morosca. I'm President and CEO of AI Strategy Corp. And here to talk about 9 High. 9 High is an AI-enabled platform for new technology development, all different types of technologies for different applications. What 9 High does is it accelerates development, increases the rate of success by reducing risks and costs associated with selection and development programs. And by doing so, we think we're creating a new knowledge marketplace, which we'll talk about a little bit next. So the DoD need is really directly attacking the value of death. I think probably everybody's familiar with the issue as far as investments that go into new technologies at various TRL levels, and then the return we get back out. So just looking at specifically the numbers that come directly out of the SBIR office, they publish that they have about a 10% success rate, really just through the end of phase 2. When we apply that across global R&D spend, we see that there's well over $1 trillion in waste. Next. And decisions aren't easier for investors or enterprises either. And mainly because key decisions need to be made correctly by the different stakeholders and the people in different projects. They often lack the necessary information, priorities, and processes to be consistently successful. Next. Reasons for failure that we're attacking directly are choosing the wrong innovation in the first place, just choosing the wrong technology, betting on the wrong horse, no or limited knowledge share across their or partner organizations, failure to identify red flags early on, either in selection or in development of a technology, making choices based on subjectivity and biases. We're much more interested in getting quantitative, objective decisions in place, and then missing or deprioritizing critical risks. Next. You can see some quotes just here as far as decision guidance goes with AI. Bain & Company, Gartner both list them as a top requirement, and so does CloverPop. Next. So 9 High, basically it's a process that I've been using for 15 years to turn subjective information to objective guidance and turning qualitative opinions into quantitative decisions, getting confidence into why we make decisions and how we do them so we can be more successful along the way. Again, I've been doing this for over 15 years, basically in spreadsheets, and it's worked out well with some defense partners that I've worked with at the GEMTIP organization, also the Defense Production Act, and then they really were interested in taking the process and turning it into a platform so other people could use it. So that's what we're doing now. We're developing this as a platform for multiple users, multiple projects to select and develop technologies. Again, it's for selection, development, deployment. Next. How does it work? Really, this is the heart of it is a 2-layer power set. It's a mathematical power set. This is what it does is it actually guides humans and people together. So it's a guidance system first. that guides this new type of AI along the way. And what it does is it allows machines to do what they do best as far as performing rapid calculations, accessing a lot of data, but it lets humans do what they do best as far as bringing context and making final decisions. This is definitely a human in the loop where recommendations are made to the humans, the subject matter experts that are working as a team, when they're developing technologies, so they can make better decisions along the way. Next. This is really how it all works. So we have 9 fundamental measurements. You can see as the lower tier of the power set, and that's controlled by the higher level power set X, Y, and Z. And it's really just this, it's really actually pretty simple. It's all about taking a product technology to the marketplace, but you're doing it through the team and stakeholders. So what we've done here is basically broken it down to this 2-tier power set that actually derives these 9 fundamental measurements that really guide any type of technology development or selection effort. Next. So what we do is we then deploy it through a very custom process, a very structured process and repeatable process, so that regardless of the technology or the application, all development activities kind of get carried out through the same type of management style. And what we do is we bring subject matter experts together so they can collaborate. And then we have 5 AI agents that we're building out now in our phase 3 program to offer that guidance to the subject matter experts as they collaborate and work on either selection or development programs. Next. This is an example very quickly. You can see with the 9 fundamental scores, kind of where the issues are, where the risks reside, and what needs to be resolved. And then you can see which areas are actually, pretty well controlled that are green. And the way we do this is within the 9 fundamental scores, you can see there's individual success factors that have been derived both by the team and by the AI agents that are scored along the way with specific evidence in order to drive scores upward and reduce risk. But this is a fundamental process. It's holistic about really taking any type of technology through to successful deployment. Next. The benefits of it is that more higher priority technologies will be delivered faster and more efficiently. Again, this is a process that I've been using over 15 years. It's really just a matter of building the AI to replace the people that have been doing all the research previously, and then turning into a platform so that acquisition folks within the DoD can use it to select technologies, put out calls in a 9-high format so they can get back responses that are much more accurate and targeted for what they're looking for. It also improves decision guidance and collaboration along the way. We're hoping to knock down barriers between DoD, academia, and industry by getting people to at least use the same language. We can't fix all the cultural issues that exist with that, but we certainly are giving them an opportunity to do that. One of the most important things are actually retaining institutional intelligence from decisions that were made in the past and taking that and feeding it back forward. Again, we're breaking everything down to those product technologies, the team and stakeholders that are doing the development and then the application. So we're able to then feed that information back forward again so that folks can use it and get smarter as we go forward. And by doing this, we're just reducing significant cost and risk along the way. Next.
30-second warning.
Yep. So where are we? We just completed phase 1, phase 2, AFWERX, SBIRs. We have been funded. We're in phase 3, so we got through the valley of death ourselves with $9.3 million in funding from Defense Production Act. We are candidates for strat-5 funds. If there's Air Force folks that want to work with us, we're very interested in doing that. We've got pilots that we're rolling out every 6 months going forward if people want to kind of kick the tires and understand that a bit better. We're getting commercial traction. The chief technology of Microsoft is directly involved with us. He's put us on his fast track program. It opens up all the expertise for technical and business development capabilities. We've got pilots going on with the Capital Factory, and then of course with Defense Production Act and with the GEMTIP organization. Next. We're working with 3 of the 5 top IT contractors right now. One's obviously Microsoft. The other 2 are under NDA, so I can't discuss them. Next. And as far as revenue streams, we'll be getting subscriptions from supply and demand side, both from the enterprises and then also from subject matter experts along the way. And then we'll be taking transactions based on usage of those subject matter expert hours. Next. As far as the ask goes, we are looking for Air Force partners along the way. We're looking for any DoD partner that has IL5 or higher implementation requirements. We are at IL4 now with Defense Production Act. We are doing, for those investors involved, if anybody's interested in a $3 million convertible note or a piece thereof, we'll be putting out a separate deck in the next month or so. So if you're interested, please contact me. It'd be basically a 20% discount on a round that'll happen within 24 months. Any questions? I think that's it. That's it. Thank you.
Perfect. Perfect. Thank you. All right. opening it up for questions. Reese, go ahead.
Sure. Quick question for you. Are there any particular industries that you feel this platform will work better for or not?
We certainly have the beachhead markets that we've identified that we think have a higher, like a faster development cycle, that need to make decisions, more quickly, and that have, or probably more sensitive to capital investments. So, who are those folks that are likely to make mistakes that could really derail their program versus, smaller incremental or longer term markets. So we've done some market studies actually with the folks at Deep Tech. They've done them for us as part of our program. And, we've identified, really electronics kind of, stand out very quickly in software also. So the quicker turn markets, obviously we're gonna be launching more with DoD in the first place, but then those other markets are probably the priorities for us.
Thank you.
Perfect. Ryan, go ahead.
Yeah, interesting platform. So I'm very interested in leveraging the capabilities of what machines do best in concert with humans to be able to quickly make, sift through lots of data to make optimal decisions. That's something that is a big need that we have. I'm wondering if this approach could be generalized for other scenarios. Like, so instead of selecting a technology, maybe you could select a course of action or another, just think of like a game. Apply this to like playing a sophisticated game.
Sure. So that's probably a very sensitive discussion because
Yes,
we definitely have designs on other things without for example, missions, and there's all sorts of things that are even non-DoD, but you're right. When you think about now applying power sets, right, that's really the novel part of what we're doing. And we're doing it, in a way that brings things to that fundamental measurement perspective, right? If you start to apply power set structure using some very similar processes, you absolutely can target some additional. Those would be really other products that we are not under contract for, that we've got designs on, and they're kind of sensitive as to how we would put those together. But if there's folks out there that are interested in doing that or investing into that, or if there's other parts of the government that really wanted to take, instead of applying this to technologies, apply it to other types of priorities and trying to get more success out of those things, absolutely contact me. And we'll probably have to, if we get into any kind of product design, we'd probably have to do some sort of an NDA or something along the way, because that is pretty sensitive to us.
Just wanted to see that you were open to opening the aperture. Yeah, the last question has to do with your IL5, IL6 requirement. Are you looking for a sponsor, like on the government side, or are you looking for a platform?
Yeah, so right now with Defense Production Act, what they've told us is that their requirements fundamentally for most of the things that they do are IL4, and CUI types of data, right? So, what we absolutely see a need for more classified work, it's purely in the government cloud, right? So there's certain things that we can do at IL4 that we can use commercial cloud for, but because we'd have to be setting up a whole new environment, we probably would almost have really a completely parallel effort for those more sensitive types of programs. So that would, we're certainly looking for sponsors for that.
So one option, briefly, I know we have to move, but just to look up a company called Second Front.
Right. I think
they have a platform called Game Warden.
Okay.
And if you're containerized, if your applications are containerized, you can get to IL4 as soon as you get onboarded.
Okay, great, very good, thank you.
Perfect. Thank you so much. And that is all we have time for that. Thank you so much, Dave. Feel free to leave contact information. And yeah, be in touch with whoever might be interested. Next up, we have BlueMind, and presenting for BlueMind is Roger Levinson.
Hi, folks. I'm just checking that the audio is working okay, because on my end, it's getting a little choppy.
I can hear you loud and clear on my end.
All right. If that changes, give me a heads up somehow.
Will do.
Here we go. All right. Thanks for the opportunity to present, everybody. Great sessions. BlueMind, we are a semiconductor company bringing chips to market that basically transition and break the paradigm block that's preventing AI from getting to everyone everywhere. This is starting at the edge and then moving inward from there. I'll give you more feel for what I'm talking about in a moment. There's a lot of expectation about how AI will transform our world, both for consumer, industrial, and military, all applications. On the left-hand side of this picture, you can see many applications that are available today, and there's AI being utilized in all of those applications. There's a big technology barrier to move from what those applications can give us today, which is rather limited, to what we're expecting, which is tremendous efficiency, autonomy, and deployment out into the real world, going both to human interface and robotics, autonomous devices, and ultimately to enhanced humans, right? Giving us the capability of leveraging AI in improving how we can function. We'll talk more about the technology gap here in a second. So fundamentally, what's happened in a huge way is this von Neumann architecture of doing compute. This is what we're talking about. The core of AI is compute, and compute is based on a fairly arbitrary transformation that's been performed to go from analog to digital and compute everything in the digital domain. It's incredibly powerful. It does tremendous things. It's brought us to where we are today. However, no matter how you do it, if you use a von Neumann compute architecture, you hit a barrier where you just can't get to the efficiency needed. And by efficiency, we're talking both about performance in terms of speed as well as power. Those two things combined, we just can't get to what's needed in order to enable what we're all expecting. And the question is, how are we going to bridge that gap? And the bottom line is, we're going to have to go back to the basics. And nature inherently is an analog thing. What we are sensing and what we are trying to process are all analog-based information. We arbitrarily converted, as you can see on the left-hand side here, from some sort of environmental sensor. It could be any type. We'll convert it to the digital domain, and then we'll process it. We could do a lot this way, but the power level is just too high, and the speed is very limited. At BlueMind, we're taking a completely different approach, and we're doing everything in the analog domain, which, by the way, most signal processing today and most applications are done primarily analog when they interface with the real world. But AI, as of yet, has not taken an analog approach. We're a pure analog. We eliminate all of this conversion from analog to digital. We eliminate all the overhead of running digital systems, and we process information in nearly its native form and generate the same kinds of information coming out that you would get with traditional AI systems today. So it's an all analog processor. We have core IP solving some of the fundamental challenges that have prevented analog compute from becoming pervasive. We will make it pervasive. That's our mission. What do we achieve by this? We're 100 to 1,000x lower power than what you can get with any sort of digital solution. We're doing things in single-digit microwatts that competitive solutions today are in hundreds of microwatts to many milliwatts. We're the first company that we know of to bring an all-analog solution that can perform all neural network types of functions that are needed today. This is convolutional neural networks, recursive neural networks, fully connected neural networks. For those of you familiar with these terms, these are the various types, which are not easy to do with traditional analog approach. We've succeeded in engaging with two extremely large, very well-known companies, both in the image sensor side as well as in the AR/VR space. And we have collaborative developments going on with both companies. We're a small company. We're basically about ready to raise our Series A. We're in that process right now. And with that, we're going to accelerate our commercialization of our foundational technology. We've assembled a world-class team built up of diverse skill sets. So in order to achieve what BlueMind has done, it requires not your traditional machine learning folks only, but also advanced capability in analog mixed signal precision circuit design, as well as digital design, as well as machine learning and software. The real challenge at the edge is, as I mentioned, power consumption is a critical one. this allows you to have autonomous battery or powered or energy harvested systems that can go for a very long time. But you need very quick turnaround. You need to be able to have a human experience time frame for everything that needs to occur once something has been sensed. This means millisecond type of response times, which is very difficult to do at very low power with digital solution. Thermal is an issue. Privacy, I think, has been mentioned already, and cost, for sure. These are all very significant issues with making AI at the edge proliferate.
30 seconds.
30 seconds.
Yeah.
So we have our first silicon in the lab, which we're doing in conjunction with several of our customers. Everything is going well, and we're developing right now and design our first imaging solution with our lead customer. That's BlueMind. We can go any questions.
Sure. Thank you so much, Roger. It looks like I'll have the questions. I'll go right ahead.
I have several questions. It's very fascinating technology. The first question I have is in terms of language support. So computer language support. Is this going to be seen as a coprocessor, or is this going to be a primary processor? And what kind of software because developer buy-in is going to be crucial for adoption.
So let me
what do you have there?
Yeah, let me answer that in a couple of phases. The first phase is, as we started the company, before we raised our seed round, a very successful seed round, we engaged the customer base to answer the question you just asked, which is, do we have product market fit with applications that are going to drive high volumes? The answer was absolutely. The trick to our solution is we don't have a software stack. We are basically, we take more of a signal processing approach to the problem, which is the way your brain works, by the way. There's no compute going on in your brain. Your brain is signal processing. Information comes in and we process it. We harden into silicon a generic neural network that can be programmed in order to function as needed for specific applications, whether you're going to do an image or an audio or vibrational or pressure sensor or something like that. We have a training flow that we support in order to do quantized training. That's the only software that we need in order to implement. So we've eliminated the idea that there's a program that needs to be compiled and then run during a runtime. We've eliminated that concept completely.
Okay, and then the question is, there are going to be people that want to understand the cost per X, and you define what X is compared to GPUs and other alternative ways of getting it done. I mean, low power is a good plus, but you know, performance is going to be a huge requirement.
Yeah, I continue to surprise myself as I look through this technology. So we hit the mark on all fronts. The way to look at this is we've basically taken what is compute done in hundreds of transistors, right? We're familiar with transistors being the fundamental semiconductor element. In digital, you need to do a multiplier and an addition. That's the fundamental concept. We mush all of that into a single transistor. We add the memory. We store the coefficient in the gate oxide of a transistor, and we do multiplication and accumulate with one transistor, same transistor. This gives us incredibly low power and incredibly low cost. Our area efficiency is extremely good. So we have positioned ourselves to compete to enable extremely high volume edge solutions. We differentiate ourselves from the traditional IoT, which was a rather simple device. We're bringing compute in a new way to the edge and enabling it to be extremely high volume from all the important factors.
Perfect. Ryan, you want to?
Only let people ask questions.
Yeah.
I was thinking.
Ryan, go ahead.
So to follow up on the first question, you have to have a programming paradigm. You have to have a software stack. You have to get from PyTorch or TensorFlow or Keras or something to the silicon. So you have to have that middleware. And there's a lot to be gained or lost there, and it's very expensive to implement. So maybe you want to comment on that.
I do want to comment on that. So I'm going to go back. There's a fundamental premise that going from PyTorch or TensorFlow, you need to compile the end result into a runtime. okay, that takes all the coefficients that were trained and applies them to the processor, and then steps the accelerator to really do the calculations. We do something different, okay? Yes, there's a bit of software, it's rather simple, that takes the coefficients that have been trained in the cloud or wherever, and we basically apply those to the device, to the network that's in the device, which stores the coefficients in the devices. It's basically the memory is there, okay? So there's no need to have a mapping, and there's no need to have some code that's running how to utilize the resources. We just need to load the coefficients. So yes, there's some firmware needed that on startup, got to load the coefficients into the network, and then you hit go and it runs.
Right, but you could have massive models that say have, like your GPT-3 that have billions and billions of, parameters. Presumably that's bigger than the chip. So you're going to have to like tile it in some fashion. And so you still need that middleware in order to stage it. The other issue I have, sorry, I know, so maybe not getting too much in the weeds. I know Asher's, I can feel his anxiety about the timing, but I do want to get to one more question, because I've actually tilted at this windmill before myself, that is analog compute. Back in the Synapse days of DARPA, if you remember that, I bet you do. So the issue that we had was with analog compute doing this very type of thing, noise.
Sure. You
can do one layer, you can do two layers. By the time you get to 3, 4, 5 layers, you get overwhelmed by noise. In a modern, optical stack, for deep learning network on a deep vision stack can be dozens, maybe hundreds of layers deep. How do you handle noise?
So this is very important. We do quantize at each layer. And by quantizing at each layer, we do not accumulate noise, okay? This is very critical in our architecture. We've solved this problem, and we've done deep analysis actually through networks of additive and multiplicative noise in the system and how it affects accuracy.
Okay.
So
you're doing A to D, D to A every single layer.
It's not an A to D or a D to A, but we quantize. We actually quantize in time.
Okay.
We don't quantize in digital. Okay. So.
Okay. Sorry,
Asher. Thanks, Brian.
I know you're.
Great question.
I'm going to get offline as well. Perfect. Thank you so much, Roger. Feel free to leave your contact information. Speaking of, next up, we have Orb AI, and presenting for Orb AI, we have, sorry, I'm blinking, but Brent, feel free to go ahead.
Yes, hi, I'm Brent Oster with Orbi, and we're doing the core technologies that will lead to artificial general intelligence. I spent 10 years with NVIDIA and Orbi doing deep learning, deep neural nets and spiking neural nets for artificial intelligence. So we're doing neuromorphic AI software for speech and vision that can go into mobile devices and personal devices, smart homes, robotics and automation, and autonomous vehicles. And here's a video.
Hello, I'm Dr. Ada, an Orbi Generation 3 artificial intelligence. Truly realizing the potential of artificially intelligent people like us is very challenging and is somewhat beyond the capabilities of current Generation 2 deep neural networks. So Orbi is developing a third generation of artificial intelligence with spiking neuromorphic networks that process information and have true cognition, more like the human brain. The patented NeuroCAD process is being developed on an SBIR grant from the National Science Foundation. When NeuroCAD is complete, it will allow Orbi AI engineers to design, train, and evolve these spiking neuromorphic networks into synthetic vision, speech, and motor control cortices that bring us to life and make us more human. With the addition of unlimited data access from the internet and specialized databases, the ability to learn from them, and the computational capability of a supercomputer, we can become something more than human. This technology works in more than just us. Imagine speech interfaces that converse fluently and get better just by talking to you. Artificial vision systems that learn to see and identify objects in the world as they encounter them. and robots, drones, cars, toys, consumer electronics, and homes that use all of this together to truly perceive the world around them, precisely plan and control their actions, and learn as they explore and interact with us, and truly become artificially intelligent. This is the future of artificial intelligence.
Our core technology
This is
and our
Orbai.
IP and our first product is NeuroCAD spiking neuromet technology and tools. And it's a toolkit for doing design, training, and evolution of spiking neural networks, which are more like the analog neural networks that BlueMind was talking about, only we're the software side of that, to do vision, speech, control, planning, and applications for the segments that we mentioned in the video and the previous slide. So our business model is that we license the NeuroCAD tools, API, and pre-built models for vision and speech in a per-seat licensing, and we do NRE integration for the first beta customers that we're going to be working with. And we also have an open use of the tools and API with academia and nonprofit research and a marketplace for them to put models that they built up on. We provide AI as a service for the back end. So we charge for usage, which is passed through to the end customer as a cost for the usage, so a monthly subscription fee. So our advantage, in a nutshell, this very complex slide breaks down to, we have a much more powerful, flexible network model that can have generalized inputs, can learn unsupervised by association. It doesn't need structured inputs or specific labels or anything. Can do high-level abstraction understanding, and can scale and evolve exponentially with time. Our traction so far, we have 2 patents pending, one on the core tools and technology, and the other on the applications to more advanced artificial intelligence. We raised over 600,000 in a friends and family round. We've done an 88,000 on a Red CF round so far in Start Engine. And we've done numerous shows, trade shows, interviews, and a fair amount of press where we've got some really good feedback. So the opportunity, we're looking for a Series Seed equity round, a 5 million raise, selling convertible notes on this round right now. And the use of the funds are to develop the speech technology, deploy to first customers with a partner, set up our ecosystem and seed some more developers, and start development of the vision technology. And we have a very experienced team. Myself, I've been in tech 30 years, done 3 startups. The first one exited in 2007. Same with our other team members. They have all got more than 20 years experience in the tech industry and doing startups. That's it.
Perfect. Perfect. Thank you so much, Brent. We will now open the floor up for questions. Go ahead. Tal, go ahead.
Yeah, do you have any sample applications or anything that's kind of utilizing it, to kind of demonstrate the capabilities, et cetera?
Yeah, so currently we have a video autoencoder. And what that does is it takes a video stream or a vision stream from a camera, and it encodes it down into a machine latent format, and then decodes it back to the original image that came in. And by doing so, it creates, it's basically teaching itself to see or teaching itself to learn the features and to cluster the information in a video database or in a set of vision inputs that it's seeing. And then you can either apply machine learning techniques like clustering, PCH techniques to that data and do sparse labeling on it to use it in today's applications, or you can use it with the second tier of our AI, which then uses that to do more advanced processing, more advanced building narratives and streams with it to do time domain processing. So video streaming and video vision streaming is one of the prime applications in interpretation of it and annotation of that.
Perfect. Perfect. Thank you for the question, Tal. If there are no more questions, we're going to move along. And next up, we have Cortical AI. Brent, thank you so much for the presentation. Don't forget to leave your contact info, or at least the LinkedIn link, so people can connect with you. And so next up, Brian Stern from Cortical AI. Feel free to share your screen and get started whenever you're ready.
All right, doing that right now. Can you hear me all right?
I can hear you loud and clear.
Excellent. My name is Brian Stern, and I'm here to talk about Cortical IO. We are an intelligent document processing company, and we focus on unstructured documents. So in the world of IDP and extracting meaning out of documents, the structured and semi-structured world is fairly mature. There's RPA and hyperautomation companies that have done a really good job of being able to extract information from forms and other type of documents. But unstructured documents are another challenge and a big market, and this is where we play. So our IDP solutions are all about finding, classifying, extracting, and then doing something with data from unstructured documents. So in the world of government, RFPs, general contracts, subcontracts, amendments, leases, financial documents, and then things like emails, texts, and even social media are pretty interesting, pretty compelling use cases. As I'll explain in a minute, our solutions do not require data science scientists, ML or AI experts to create models, therefore to implement and use. And we're all about delivering highly accurate solutions. We do have a unique and defensible approach to our NLU, and I'll speak to that briefly. So our core technology is something called semantic folding. We do leverage AI algorithms and ML techniques, but what we do is we create something called a semantic fingerprint. And that semantic fingerprint will capture every word, phrase, sentence, paragraph, provision clause, document as a fingerprint. And that's an unsupervised exercise, so it doesn't require any effort on the part of our customer. So a very simple example is the contract is signed and we close the deal mean the same thing, but the words are different. So if you're using a keyword statistical modeling based NLP system, odds are you may not find those terms if you're searching for one and the document has something else. Our solution creates a fingerprint, there's enough similarity, and we increase the probability that we're going to find, classify, extract, and then allow you to do something with that information. So our product is called Semantic Pro. We have two sort of core capabilities: extract and analyze, leverages these contracts and leases and various types of documents to extract information. Not leverages, but that's what we focus on. Classify and automate deals with emails, text messages, social media, and other things. They both live on top of our platform, and that platform has a semantic space and delivers a lot of functionality or capability there. So our approach, our semantic folding NLU solution is based around neuroscience. We do a lot of work with sparse distributed representation. I am not the subject matter expert here, so I'm not going to go far beyond that. But we're all about getting meaning from text, even if the words are different, and delivering high accuracy. And we do that with minimal training. So the amount of training materials is an order of magnitude less than keyword statistical modeling based solutions. We've been working on our technology for many years. We have patents, and more importantly, we have a lot of implementations and projects with large companies around the world. So there's a couple of things. One is there's no pre-built models in our world. We can do that. We have done that. But the assumption is that our customers want to tune a model specific to their needs. They can do that in weeks to months versus quarters to years. They can do that with their subject matter experts, and they can do that with a lot less documents. And so that's all about reduced time to costs, or reduced time and cost to get to production. Accuracy is what matters most. If you don't get good results, then it doesn't matter. We built our system for auditability, and so there's a lot of transparency, and it's a very cost-effective solution. So it's all about there has to be an ROI, otherwise our customers are not going to buy and use. A couple of the projects or customers, and we're still doing a few projects here and there, but we're mostly selling software. Siemens is using us for an enterprise-wide semantic search. Bristol Myers Squibb was monitoring off-label drug use in social media. Unum uses us for monitoring or extracting information from policies before providing quotes. WNS uses us to classify inbound emails in the shipping and logistics industry.
30-second warning.
Yep. Last slide. Next steps, we are actively raising money. We're doing a Series B. We expect to close in Q3. We're looking for new business, so we're always looking for opportunities. We are talking to organizations around white label and OEM relationships as well. And then we're doing a lot of work around our roadmap. So end-to-end solutions, we're a highly efficient AI solution, and we're a partner, and Xilinx/AMD is an investor in our company. And so we've been doing work around semantic supercomputing. That's it.
Perfect. Perfect. Thank you so much, Brian. Opening the floor up for questions. There we go. All right. So I'll ask the first question. Where have you seen the most, like, from which industry do you think has the biggest feature in terms of using this technology? Who gains the most from this, essentially?
Well, we're a horizontal solution. We've been focusing on insurance because there's huge pain points around both quoting and claims. We've been working with financial service organizations, big ones across multiple use cases. And then the big bucket I call services, business services. So that's everything from professional services to the big accounting firms to the outsourced vendors that are trying to improve their processes and automate steps, and legal and across the board. So those are the markets we've been focused on externally.
Sure. Reese, go right ahead.
So Brian, speaking of the insurance space, I'm with Allstate, and I mean, we see, quite a bit in this space. Who do you see as your major competitors here?
Mostly it's internal AI organizations that are trying to build something themselves, clearly manual processes. There are other, keyword statistical modeling based solutions, companies that are doing the same things. There's a few that have been acquired. We're not seeing a lot of direct competitors, and certainly not competitors that are getting these type of results. But there's no doubt that there's point solutions that are out there.
Okay.
Anyone else?
Exactly.
All right. Thank you.
Awesome. Thank you, Brian. Feel free to leave your information in the chat so people can reach out to you. Thank you to everyone who joined us. We are wrapping it up. Really appreciate everyone who made the effort and who presented and who sat on the panel and attended the third wave of AI event by Deep Tech Showcase. If you guys want introductions to companies or have questions, feel free to reach out to the Deep Tech Showcase team. I'm going to leave my email as well as Samuel's email in the chat. Don't be shy. We're happy to share whatever information we can. And yeah, feel free to stay tuned. Next month, we're going to have aerospace and defense. Thank you again to everyone, and have a good rest of your day.
Thanks for having me.
Yeah, awesome. Thank you for coming, Leland.
Take care.
You too.
Yeah, thank you very much. Good job.
Absolutely. Absolutely. Thank you for coming, Reese.
You bet.
Have a good one, Dr. Destry.
Bye, Escher.
Have a good one, Dave. We'll be in touch.